Welcome back, everyone. We're here for day 2 of the completely free AWS Solutions Architect Associate 2023 Bootcamp. In this bootcamp, we're focusing on the AWS Solutions Architect certification, and this is an AWS full course tutorial. We do this free AWS certification training because we've done so many interviews of AWS certified people, and we see everyone that knows how to configure something, but not what to configure, why they're configuring it, or how to configure. And when you're on an interview, nobody's going to ever ask you to configure something, but they will ask you about the technology. You must be able to explain what is the tech, how does the tech work, and what benefits it brings to the company. So that's why we're going to go over these concepts very deep. Again, this is a free AWS course for the SAA C-CO3 exam. Before we begin, I want to tell you about a couple of cool things we have for you, and they're all free to help you in your cloud computing career. There is an exam guide that we wrote that covers the Certified Solutions Architect Associate and Professional. It's a completely free ebook. It's a companion that's designed to go with this course. It's more AWS specific, and we want you to get it. It's completely free. The link my team will put in the chat box and should be in the description of this video. On top of that, tonight we're going to have an extra hour and we're going to talk on Zoom. And if you join this boot camp, you'll be able to ask your questions. We'll have some fun. Last night we got a little geeky. We got to do some cool stuff that we could not do on YouTube. So sign up for the extra boot camp session tonight. We're going to give you good information, and we can have a face-to-face conversation like a real class. And tomorrow, here's the big one for you. Now that you're certified, how do you get your first cloud architect job? And we get people hired absolutely every single day of the week at every company you can possibly think of, whether it's AWS, whether it's Azure, whether it's Apple, whether it's Cisco, whether it's IBM, whether it's Google, whether it's Accenture, Deloitte, KPMG, Capgemini, the British Broadcasting Company, JP Morgan Chase, and so many others. And it's completely free. We're going to give you the entire list of skills you need to get instantly hired as a cloud architect. There's a lot of jobs out there, but you've got to have the right skills, and they are very different than certification skills. Certification is great. It's going to get you an interview. And we need an interview to get hired, right? So we love certifications for this. But getting hired is not about certifications. It's all about special skills. And we'll talk about all of them tomorrow morning at 10 a.m. So join us at 10 a.m. We'll have a presentation for about 30 minutes. And then, of course, I'm all about helping you get to your goals, and that means answering your questions. So we'll be live on Zoom. We can have face-to-face conversations. I can give you mini interviews. I'll do anything I can to help you get your first cloud architect job. Join me tomorrow. It's free. I strongly encourage you to sign up. In fact, I'm going to say, please sign up. It may change your life. So I wanted to get all those things out there so you know about. They're all free, and they're all there to help you. Tell me where you are from. I saw some people in Jamaica, which is great. That's like very close to me. I spent a lot of time. I see some people from Kenya. Simon, welcome from Kenya. Welcome from Equatorial Guinea. I love that. That is fantastic. We've got people in the UK, which is fantastic. Jamaica, Craig. You know, like I said, I had some saltfish and ackee, but I also had some bammy this morning too. I guess you wonder where I'm from. And Lebanon. I haven't been to Lebanon in a while, but I've had a lot of great times there. And Lagos, Nigeria. I love this. San Francisco. I love it. Fort Washington, Maryland. Chris, that's fantastic. Nigeria, Mufaz, wonderful. Alonzo, part of my team in Katy. Gambia, that's terrific. I haven't been there, and that's one place I want to go. FB in Canada, fantastic. Sao Paulo, South Africa, India. See, this is great. Pakistan, okay, great. We've got more. South Florida, that's where I'm at. And New York, I used to work there. So, you know, I love this. This is really terrific. And Boca Raton, you know, one day, you know, we're not too far away from each other. So, fantastic. So, we're here. Now, let's come up with a fun hashtag and call it Fun AWS Day, and then we'll begin. Takes a few minutes for YouTube to tell everybody, join, join, join. Philadelphia, I grew up there. India, I say, okay, sure, it's so good to see you. UK, I love it. Germany. Texas, Richard, you're in Texas, it's always good to see you. I always forget that you're over there in Texas. Prudence in South Africa, I love that. And Fun AWS Day, Chow, who's in Dallas, all the way from Vietnam. And Leo's part of my team. He's on Sao Paulo. Fun AWS Day. Okay, this is great. I love it. You are now all awake, alert, and oriented. And for all you Philly guys, my wife's actually in Philadelphia right now. I still have a house in Philadelphia, in Northeast Philadelphia. And, you know, my wife's coming home today, so I'm all kinds of excited and bouncing off the wall. So let's talk about databases. We're in an AWS Bootcamp. We're going to talk about databases, and we're going to give you the certification information. We're also going to give you some information so you know how to actually architect the databases in a real-world environment, which is very different than in a certification environment.
Mr. Producer here.
Chris, if you can mute out, you got some kind of feedback on your end.
Yeah, how's it sound now?
Okay, so we're going to begin with an introduction to databases. And actually, you know, before we begin, you know, please invite somebody else to this session. Share a copy of the video with this session to others. You know, cost almost as much as a car to put a production like this on. You know, we've got 10 employees working full time, and we're talking expensive people. We've got a lot of technology that goes into these things, lots of high-end video, lots of encoders. So we do it to help you. So please share this with somebody else. Tell a friend to take advantage of the free training. So now let's talk about some AWS databases. So to begin, what's a database? A database is basically an application that enables you to store large volumes of information. Now, okay, can a hard drive store large volumes of information? The answer is yes. Yes. And the databases themselves enable you to sort the information, make calculations on the information, report on the information, and share information. So it's not just a place to dump your stuff. It's a place to be able to put your stuff and be able to take actions upon it later. And in today's world, databases are an absolutely critical application. Now, when we talk about databases per se, there are basically three kinds of databases that we'll really talk about. And they are relational databases, they are NoSQL databases, and they're actually data warehouses. We'll also talk a little bit about a data lake and what it is. And if you want, maybe we'll architect a data lake out there to show you the data lake environment. And it's nothing like they talk about in a certification. Let you that know as well. Are we having any troubles with the audio? Because I can make some adjustments on my side. Chris, what's at me if we're having an audio issue?
That was my audio.
Okay. Okay, so we're beginning by talking about relational databases. And they are the most common databases out there. They are everywhere. And relational databases store information that's related to each other. I'm going to say it again. The point of a relational database is to store information that's related to each other. So data is going to be stored in rows and columns, kind of like a spreadsheet. And that's something I need you to understand. Why would we want to know that databases are related to each other? We want to know that it's related information because if I'm a company and I can determine that people buy at a 20% off discount, I can analyze that information from my relational database, and it can help my chief marketing officer, for example, in a company, determine the pricing strategy for a product. And that's why organizations are dependent upon relational databases, as well as storing transactions of the such. And relational databases are what's considered atomic. And what that actually means is once you write information, it's consistent across all nodes in the databases. In fact, they adhere to something called an ACID model, which means atomic. The transactions are all or nothing. It's either written or it's not. The consistency of the data. The second I write it to this one database server, it's on all my servers instantly. The transactions are isolated, meaning one transaction does not affect another. And it's durable, meaning once the data is in the database, unless the hard drive fails or the virtual hard drive like block storage fails, the data is not going anywhere. So atomic, all or nothing, consistent. Immediately after a write, it's consistent across all nodes. Isolated, one thing doesn't affect another. and durable. It stays, it's strong, and that's really what we're talking about. And when I talk about columns and rows, it's going to look similar structured like this. You can see information about a person or their company, the purchase price, the emails, the product set, those kinds of things. That's why organizations use relational databases. And why do they use databases at all? To assist the business in making better business decisions. Otherwise, these databases would be a total waste of time. They need to make better business decisions or store transactions. Oops, don't know what I did there. So when we talk about databases, we're going to talk about a lot of them. There's managed and unmanaged, and they both have major trade-offs. We'll talk about Amazon Aurora. We'll talk about MariaDB. We'll talk about Microsoft SQL Server. We'll talk about MySQL briefly. We'll talk about the Oracle database, which you guys get real familiar with, and Postgres, which is typically used as a data warehouse. So before we get into Amazon Aurora, I want to caution you. I'm going to tell you this. Amazon Aurora is a great database, and it's managed by AWS. I'm also going to tell you that if you use this, you just messed yourself up in multi-cloud because you're using something that now is proprietary, and you can't put Amazon Aurora in Microsoft Azure, Google, Alibaba, or any of these things. So now that you know that, in many cases, you probably should just avoid Amazon Aurora. It is proprietary, unless you're going to only have an architecture that only exists on one cloud. And if you do that, what happens a year later when the company wants to move to 2 clouds or multi-cloud, like 98% of organizations? So Amazon Aurora, we're going to cover it. Understand it will make multi-cloud challenging, if not impossible, well, at least very challenging. So know that if you use it, you're causing challenges for your customer later. Now, it's a fully managed database, which means one thing. You don't have control over it. It's just done for you. So understand that. Now, if you don't understand infrastructure, and you don't understand servers, and you don't understand storage, Aurora is great because you don't have to know anything, and it'll just work until it breaks, until things get, until you reach a scale, and then you need to understand your underlying infrastructure, and everything falls apart. But it's good because it's managed. So less to do, less skilled people. You have to pay less for your staff. So there is that. Now, it's relatively high performance. Amazon will tell you it's upwards of 3 times faster than MySQL and 3 times faster than Postgres. And the reality is this is a very good database, other than it's proprietary and you can't use it in multi-cloud. And 98% of customers are multi-cloud. So what's nice about Aurora is they take a lot of the features and functions from an industrial database, like an Oracle database, and they include it here. But understand, there you go. Good quality product, proprietary, locks you into AWS forever and makes multi-cloud very challenging. Now, the next database that we're going to talk about is MySQL. Okay, MySQL is a freeware database. It is an open standard. It is a great database, and it is one of the most common databases on the internet. Oracle owns it. I believe it was developed by Sun Microsystems a million years ago before Oracle bought them. It's not the most scalable database, but you'll see it everywhere. You'll also see the Linux, Apache, MySQL, PHP stack, which a lot of web applications are done. So this is everywhere. It's an open source relational database, and it's incredibly common because it's free and it works great. The next database isn't really a database. It's more of a data warehousing database, but it's still a database, and it's called Postgres. And again, this is an open source relational database. It's a great database. Lots of people use it as a data warehouse. It's got a lot of features. It's got phenomenal functionality over MySQL, and it's an open source database. Now, I mentioned MySQL had some weaknesses to it, but it also has some big strengths. So the people that made MySQL made MariaDB. And you know what's great about MariaDB and MySQL and Postgres? You can run them in AWS, Azure, Google, Cisco's cloud, Alibaba's cloud, Dell's cloud, HP's cloud, all at the same time. No interoperability problems whatsoever. Now, MariaDB basically took all the weaknesses in MySQL and fixed them. So MariaDB is another open source database. It's a phenomenal product, and it works across all clouds. Now, the next database that we're going to talk about, and actually, before we get into this, I want to let you know, these are the 3 most commonly used databases in the world. MySQL, Microsoft SQL, and the Oracle database. 3 most common relational databases in the world. Why? They work, they're phenomenal, they've got great support, or free. One of the 2. Microsoft SQL is paid. And Microsoft SQL is phenomenal if you're working with Microsoft-related workloads. And AWS has multiple options for you to run the Microsoft SQL database. You can use a standard Microsoft SQL database, SQL Server 2008, SQL Server 2012, SQL Server 2014, for example. And that's to help you bring your Microsoft workloads to the AWS cloud. But I like it because you can put Microsoft SQL on 3 clouds at the same time. No information exchanging problems, so it's fantastic. It's fairly highly reliable, and there's options up there. Now, there are 4 versions of Microsoft SQL database. The Express, which is pretty light, the Web, which is also on the lighter side, the Standard, and the Enterprise. You can choose any of these options, and they work. And now we're probably going to get into one of the best of all databases in the world, which is the Oracle databases. And Oracle is, realistically speaking, one of the most popular relational databases in the world. I think it's #1 in enterprise database market, meaning the big companies are all using this. It's got a huge feature set. It's incredibly scalable by the number of nodes you can read and write on. I mean, this is a serious database for serious business. And it works on all clouds. Now, the Amazon database management system typically gives you the option for Standard, Standard 1, and Enterprise. And they're typically your databases that you can run. Now, there's a couple of licensing options because this is a paid product. And you can use license included with AWS. And that'll give you Standard Edition 1 and Standard Edition 2. Basically, what's going on here is Amazon is paying Oracle for the license, and they're billing you a certain fee to run their database. Now, that's good if you want some of the options. But what if you want all the options? Well, you can bring your own license. Meaning, you can set up the Oracle database on a virtual machine like any other virtual machine. You can set any of these databases up the old-fashioned way, too. You don't have to use anybody's managed anything. But you do this. If you bring your own license, you can use the Standard license, the Enterprise license, the Standard Edition 1, and the Standard Edition 2. So you've got much more flexibility. Now let's talk about NoSQL databases. Well, a NoSQL database stands for not only structured query language. And NoSQL databases are not new. None of this stuff is new. I mean, they may market it as new, but NoSQL databases were invented by IBM in the 1970s. So old technology, pretty sure it was IBM. And they work with structured and unstructured data. So very flexible, which allows to scalability. Flexibility in the way you structure your data. Like I'm stuck in a video game here. I'm watching The Vampire Diaries and I'm on season 5, episode 3. By the way, if you haven't seen The Vampire Diaries, my wife got me addicted to it and I've been watching it every day. And yesterday I watched season 5, episode 3, and I paused it there. And it got stuck in somebody else's relational database. So when I go back tonight, when my wife comes home and we've got 10 minutes to watch The Vampire Diaries, I'm going to be in the same place that I was last night, which is pretty cool to me because we can do that with a NoSQL database. And because we're flexible with a lot of things, NoSQL databases can scale to a very large majority. And we love that. So keep that in the back of your mind. So NoSQL databases, highly flexible schema, and they are not bound to like a column and a row like you would see with a relational database. So we've got a lot more we can do here. Less structured data, much more scalable. And of course, we've got options for databases. And I'm going to talk about managed versus unmanaged, and I'll talk about proprietary versus non-proprietary. AWS has a very good NoSQL database that they made for themselves called DynamoDB. It's great. I mean, it's really great. The only problem is, once you use it, you're kind of stuck with your single cloud. And 98% of enterprises are multi-cloud. So the reality is, I can't use it for 98% of my customers. Now, I can use MongoDB or Apache Cassandra, which are NoSQL databases that work great. I mean, they work great. Apache Cassandra lets you write on all nodes. So you can literally have 30 nodes out there in 3 different clouds, and they're all writing at the same time. And we'll talk about read and writing soon and how to scale these databases. But that's phenomenal. MongoDB doesn't let you write the same way, but it scales more for read. So you got to understand your traffic when you pick these things up. But understand, if you use DynamoDB, you are in trouble with 98% of multi-cloud deployments. It is a great database, though. So I don't want you to think I don't like it. I love it. But I don't like single points of failure, and a single cloud's a single point of failure. So you can get a fully managed database from DynamoDB. Now, what does this mean? It means you don't have to think about the server capacity. You don't have to think about the storage capacity. It just works. Now, which do you think gives you better performance? A professional photographer with a camera where they do everything manually and they set the lighting and they set the adjustments and they set the f-stop and they build you a beautiful photo? Or when you take your iPhone and you click picture? It's the same thing with databases. Managed is like going to McDonald's and having somebody get you your burgers, your fry, and your Coke. And unmanaged, where you manage yourself, means you can be the chef and you can make it as good as you want. So understand that. It's a trade-off. One is a lot more work and gives you a lot more flexibility and a lot more performance. The other just works. You have to choose to make the right decision for the business's needs. So DynamoDB is fully managed. It's serverless. You don't have to think about patching operating systems or security. You got to hope they do the security right. Of course, the competitor, Microsoft Cosmos, was hacked, and thousands of customers' information was stolen because it's a managed service, and that's what happens in these environments. These are the risks that you have to understand. But it's a great product. And DynamoDB stores its information on SSD drives. So let's talk about databases. The DynamoDB's got low millisecond latency. You can also use a cache, an in-memory cache that can lower it to sub-millisecond. When you use a cache, if it's all different data, the cache adds latency and makes it worse. If it's all different data, if it's all the same data, the cache helps. So again, don't just stick stuff out there. You got to understand the business needs. DynamoDB will encrypt all data by default, which is great, and it can be backed up with little or no performance on the database, which is really good. Like I said, it's a great database. It's just a problem in multi-cloud. It can be set up for global cross-region replication. So it's designed to work with name-value pairs, like a primary index DynamoDB. It can also work with secondary indexes, which allow applications to have access to different query patterns. You can also create a DynamoDB secondary index, which can be either global or local. And local secondary indexes will have the same partition key as the base table, and global indices will span across database partitions. Point is, you can take your database, you can chop it into little mini databases, and that's how you scale these things. Now, we can't get a key value to exceed greater than 10 gigabytes. That's pretty big, so it's generally not a problem. And to increase scalability, DynamoDB, like most SQL databases, is eventually consistent. What does that mean? Remember with the relational database, I said, Mike Gibbs buys Cindy the cat 10 kilos of tuna, and therefore all databases will have that? And yes, I probably buy more than 10 kilos of tuna for my pretty little princess cat. She gets a lot of fresh fruit. That's neither here nor there. Now, on DynamoDB, or any NoSQL database, I might buy my tuna, and this one node of the database might say, Mike just purchased 10 kilos of fancy albacore tuna for Cindy the cat. The other databases may not have that information in their database for 60 seconds. 1 second, 2 seconds, 3 seconds. Not long. But the time that it takes maybe 1 second to get to all the other databases, that reduces the load on these databases, which means they can grow larger and faster because it's less work. It's constantly not trying to boom, 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 sync. And by doing so, it scales better. Now, if you want DynamoDB to be immediately consistent, you can go do that. You really can, and it's your choice. But if you do that, it costs you scalability. But here's architecture. Architecture is evaluating all the trade-offs of all the various technologies and figuring out which one best meets the business needs. It has nothing to do with the tech itself. It's all about the business. So kind of keep that if you need. Now, DynamoDB typically is provision capacity. You tell it what you need ahead of time. Now, the good news is DynamoDB auto scales as well. If you don't know, you can pick something, let it auto scale out. And in the old days, it didn't scale back in, which was terrible, but now it'll scale out and scale in. So that helps you. And if you've got information that you're not going to access frequently, you can create an infrequent access table, like a little partition of the database, and therefore you pay upwards of 20% less to save the data. But guess what? I got to pay to retrieve the data, so nothing's free. It's about choosing the right option for your organization. So when would you use DynamoDB? When would you use MongoDB? When would you use Apache Cassandra? When would you use the NoSQL flavor of the day? Google has their cloud big table. Microsoft has Cosmos. Probably wouldn't use, I don't use any of them for the most part because everything I do is multi-cloud. Because in my world, people come to me for high availability, and that means no single clouds. So, but not every business has those same needs. You have to base it on the business needs. But for any of these NoSQL databases, if you need unlimited scalability or close to it, use a NoSQL database. If you're looking for relatively low latency, use a NoSQL database. Let's say you've got 10 million Internet of Things devices out there, like telling you what the weather sensors are all over the world, or airplanes coming in constantly saying, I'm here, I'm here, I'm here, I'm here, I'm here, I'm here, I'm here. And NoSQL database is perfect because of the scalability. Now, I don't play video games. I haven't since Pac-Man, but my brother plays video games. I build him special computers, and he pauses the game, and it saves his state. That's because a NoSQL database is ideal for this. I do occasionally watch a movie, and storing where you're at on a NoSQL database is great. And Apache Cassandra is really great for this because it writes on all nodes. Netflix is using Apache Cassandra for a reason. It scales, and it works great. Leaderboards, those kind of things, that's where you can think about it. How about a bank that's got millions and millions of transactions that are processing stock trades? Perfect use case for a NoSQL database. It can also be used for shopping carts or inventory tracking, customer profiles of accounts and who's using access to what. So kind of keep that in the back of your mind. So next, let's talk about a data warehouse. What is a data warehouse? A data warehouse is a place to store a large amount of information. Why do businesses want to store large amounts of information? You think it's fun for them to say, hey, let's spend a lot of money on databases? No. They're storing large amounts of information. They have access to good information so they can make better business predictions. The whole point in business is they're making educated guesses. Everything is a risk. And the more information you have, the better you're there. That's why when I used to practice internal medicine, I spent 10 minutes asking my patients questions to find out about their medical condition long before I came to a diagnosis and wrote them a prescription. Same thing for the architect. It's mostly about the questions we ask, especially since we don't touch the technology. And the data warehouse is the perfect place for business to store all its stuff. And by storing all its stuff in a data warehouse, it enables us to get really great information to make better business decisions as time moves on. So that's the reason we use databases. Now, when we're using a data warehouse, we typically have put it in there in a few ways. We typically have to get the information from our databases, which typically means some form of extraction, translation, and loading, or extraction, loading, and transactions based upon the CPU and performance you've got of your systems and your disk performance. But typically, we need something to prep the data, to load it into the data warehouse. We need something to look at the data and see what it is. And after that, we may need to prep the data in and out of various things that we actually have. So that's really what we're talking about. Now, again, I wouldn't be using Amazon Redshift in my world because the world I deal with is all multi-cloud. Everybody comes to me that needs 99.999% available systems, which means multi-cloud. But a typical data warehouse would look like something like this. You might have your object storage. You probably have a Python Spark script or a proprietary managed service like EMR, which will get your information into your data warehouse. In this case, we drew Redshift. And then you're going to need a visualization tool like Power BI or Amazon QuickSight. Again, Power BI can be run in all clouds, even though Microsoft makes it. So I use stuff that can be working in all clouds. But that's really what we're talking about. But it's an Amazon exam, so we're going to talk about Redshift. There's really great industrial products like Snowflake for data warehousing that run on all three clouds simultaneously, and they've got an extraordinary feature set. There's other big data warehouses that are out there as well. So Amazon Redshift is the Amazon branded, Amazon proprietary, Amazon managed data warehouse solution. And companies use it to get some actionable insights from their data, meaning how they can make better decisions. They use it for business analytics. And Amazon Redshift Spectrum can provide real-time insights into your data, your business, and it can even work with other services like object storage or S3. Amazon Redshift is relatively fast, powerful, but it's fully managed. So like I said, do you want to go to McDonald's and get your hamburger pre-made for you, or do you want to build something custom and have what you need? Kind of like going to the best restaurant and asking the chef to make you what you need. It's a choice. Sometimes you want a fast food burger. Sometimes you want the best. What do you need for your business? Amazon Redshift allows for petabyte scale warehousing, and it's based on Postgres, which, as I mentioned, is a great data warehouse. Because it's based on it and then tuned, it'll enable you to run some SQL queries on it, and it works great with applications that use SQL queries. Now, how does the Amazon Redshift architecture work? Well, it works in the following. It's built around clusters of computing nodes. The primary node, main node, is considered a leader node. And all the other nodes support the leader node. So kind of keep that in the back of your mind. And queries are directed at the leader node. I'll get into data lakes for a minute, and maybe we'll stop after data lakes. And then we have to talk about scaling databases and setting them and all kinds of stuff. But what is a data lake? A data lake is a repository that enables you to store structured and unstructured data. A data lake is an application that holds large amounts of raw data, and it does not require you to structure your data as you would in a traditional database. What are the benefits of a data lake? It enables you to store all kinds of information, and you leave it there, and you can keep it for when you're ready to use it. It's adaptable, it's changeable, but it's keeping the information in native format until you need it. And then you can search and get what you need. Now, this is kind of what a data lake will typically look like. You'll typically have a NoSQL database, a data warehouse, and a relational database. You'll transform your data. I put data transformation in there, and that data transformation is really more of a Python Spark script. Amazon has a fully managed system like that called Elastic MapReduce. And then you're going to put it in object storage. Now, this is only part of a data lake. For those of you that really want to know all about a data lake and how you design them, we have an incredible data lake discussion on our environment and on our YouTube channel. We have a really fantastic big data architect, Praveen Diwali. He's a good friend. He was a big data architect. He came to me. We retrained him as a cloud architect. Now he works as a cloud architect for JP Morgan Chase, but he's an expert on big data architects, and he's a big expert on data lakes. And when it comes to learning, I like to bring you the best of the best and people that have spent 20 years on one thing. So that's Praveen. He's an expert. You can see a video on him on data lakes on our YouTube channel. Great video. I encourage you to see it. So I've been talking for a little bit. Probably time to try and open up and look and see if there's any questions, and then I'll get back into the content. What about MongoDB? MongoDB is an absolutely incredible NoSQL database that you can use in any cloud or any data center. One of my 2 recommendations. MongoDB actually made some changes recently, so it can actually process transactions as well. So you could use it in some cases as a replacement to a relational database, or in addition to a relational database. It is a phenomenal NoSQL database. We recommend MongoDB when there's heavy read load. By comparison, Faizan, we recommend Apache Cassandra, typically speaking, when we have a lot more write load. And here's the reason. Apache Cassandra can write on all nodes. MongoDB cannot. So if your write load is heavier, use Apache Cassandra. If your read load is heavier, or pull load is heavier, use MongoDB. Great. Great points about flexibility versus total cost of ownership. If a business isn't going to hire and manage resources, manage service from the cloud provider, it may make sense. Absolutely. Well, Brett, that is true. The problem is, if you basically don't understand how any of your systems run, because you don't have the right technology people, you ultimately get to a situation where you find yourself now trying to solve bigger problems that occur later. It's called technical debt. But here's the real thing. It's all based upon the business needs. It's not about the tech ever. And I'm thrilled that you saw that it's not about the tech. Here's why people pay me to consult as an architect. They say, Mike, here's the business challenge I have. Figure out a way to make it work. That's architecture. It's never about microservices versus monolith. It's never about Cisco versus Amazon. It's never about who makes the best firewall in the world. It's all about what solution is best for my customer's specific problem. And that's one of the things that scares me. I come from medicine. Imagine a doctor that only likes Pfizer medications. Here, you can have Zithromax. Here, you can have this, but only Pfizer drugs. It'd be ridiculous. Physicians use every tool at their disposal. And it would be ridiculous for a cloud architect to limit themselves to just AWS or just Azure or just Google. You got the whole tools belt. You've got Palo Alto and Fortinet and Checkpoint too. You've got F5 and you've got all these great companies that give us great solutions to help our clients. Let's go to the next one. Will it scale beyond your starting provision? I don't know what that's related to, Chris. If it's DynamoDB, it will auto scale beyond that if it's set up, yes. But I'm assuming you're talking about DynamoDB. I don't actually know what it is. Does NoSQL like MongoDB store data as JSON? I'm not sure about the level of code that it stores its data in. And I'm an architect. We don't touch the tech. We don't code it. We don't configure it. We design it, present it, sell it. So. FB, since you mentioned multi-cloud a number of times, we're talking about data replication across different clouds, say MySQL. Can I explain further how this can be used? FB, I want you to think about this. Let's say we've got Oracle, which can write to 2 nodes. Does it matter whether they're sitting next to each other or 1,000 miles apart if we've got IP connectivity with them? It doesn't matter. It's the same way we've done it for 20 years. So all the people that have never worked in a network in a data center say multi-cloud is complex. But we've been doing this for 25, 30, 40 years. We split our applications across data centers, and that's why we have a network between them. So got 2 things, they synchronize. No big deal. So that's all basic networking. So if that's not there, make sure you learn networking. Because if you understand networking, you understand that it doesn't matter where you're at as long as you can reach it. Good question, though. Please explain the difference between the data lake and data warehouse. Tully, I want to invite you to join the extra bootcamp hour sessions tonight because I can actually draw them out for you. I also want you to see Praveen's video. A data warehouse is just basically a database where you stick your stuff in. Think of it as a giant database. A data lake is where you take the information from your data warehouse, from your relational database, from your NoSQL database. You normalize the data so that Mike Gibbs looks the same instead of all caps Mike and then and one and lower all lowercase and another, because otherwise the database doesn't know. We take our data, we normalize it, we put it in object storage, we catalog the data, and then we can see the data and do things. So massive difference between the two. If you come tonight, I'll work through and I'll draw it out for you architecturally. But you say got it, so that's good. Can a data warehouse also work with a NoSQL data? A data warehouse is not a NoSQL database, it's a data warehouse. So we use data warehouses to store various amount of information for business decisions. We use NoSQL databases due to their scalability and their ability to store information. And we use relational databases typically for tracking transactions and data that's related to each other. Emmanuel, each tool has its use. So we want to use the right tool for the right job. And chances are, any company you work with, they're going to have a relational database, a NoSQL database, and a data warehouse. Is MariaDB the same thing as MySQL? Nope. It is it is an enhanced version. It was created by the same people, but they made a better version. Kind of like the car that was invented in 1950 by Cadillac might be different than a car made by Mercedes 50 years later, or even a car made by the GM 50 years later. Totally different product. Can I explain what a node is? Yes, it's a server. I was told the solution architect writes code. That is completely not true. The job of the architect is design. How do you design solutions? Sagun, you have to first come to the webinar tomorrow where I'll tell you every skill that you need to learn. But as an architect, your critical skills are business acumen, CXO relevancy, leadership, sales skills, emotional intelligence, and the ability to understand the network, the data center, the cloud, and to design the solutions, to be able to present the solutions back to the customer, to be able to help sell that solution and help negotiate it. The solution architect or cloud architect will never code. If a solution architect at AWS, Azure, Google, Cisco, IBM, Accenture, Deloitte, KPMG, Capgemini were to touch the customer's environment, they would be fired immediately and escorted out by security. Architects focus on the business, engineers build it. So completely different job for completely different people. Which DBA do you think is knowing? A DBA is a database administrator that is a person. Which database do I think is knowing for the multi-cloud user? Well, Microsoft SQL, Oracle, MySQL, MariaDB are one. Postgres is another one. Anything that is not made by the cloud provider that will work in a multi-cloud environment. For transformation, would AWS Glue be more appropriate compared to AMR? Craig, the reality is people are going to write a Python Spark script and they're going to customize it for their own needs and they're not going to use any of these services. So it depends whether you're mapping and reducing or whether you're using these things. Most customers, again, they're multi-cloud. So why would they try to figure out a proprietary AWS tool and a proprietary Azure tool and a proprietary Google tool when they can run script that's going to run on all clouds? So again, these are one of these things which we'll talk about, but in my world, I don't have a lot of use for proprietary anything. That's the difference between certified and hired. And that's why we have to spend so much time retraining people that have a lot of certifications, because the certifications point you to do things which might be really bad for multi-cloud. Can you migrate a database from on-prem to AWS? What strategies? Say, JP, I want you to learn networking and data center technologies. Join us tonight. And join us tomorrow on the How to Get Your First Cloud Job webinar. You've got a database sitting on a virtual machine in your data center. If you really want it, you could just take that virtual machine, literally convert it and move it to the cloud and have that identical virtual machine running with no changes without using any of the AWS database, anything. Or you could use one of the Amazon database migration services. So kind of think about that, what you're actually doing with. The choice of all of these is always based upon the business needs, though. And you test the database the way you would test any other database. You query it. You try to write to it. No big deal. So let's get back to the content. Come back tonight. And we'll do some things on Zoom. We can draw stuff out, sign up. It's completely free. And make sure you come tomorrow. For the people that are asking how to go from zero to hero, first, it's the wrong question. How do you go from zero knowledge to a cloud expert? And then the key is understanding which career you want I'm on, because I want to help you. AWS is just the brand. I want you to know it all, because if you know it all, you can get great jobs. So let me know you're awake, alert, and oriented by giving me a hashtag SAA-CO3, Sierra Alpha Alpha-Charlie 03. For those of you that use the phonetic alphabet, come from a pilot or a tactical background or military background. That way, I know you're here. SAA-CO3. I'm loving it. I'm seeing a lot of these SAA-CO3s. That means you are awake, you are alert, you are oriented. I come from healthcare, so I got to know that everybody's there. Yeah, so thank you so much. I saw some of your nice comments. I really appreciate that. Good to see you, Fernan, and Augustine, and Tina, and Rohan. And for the Cindy lovers, I love that. So in the end of this, we're going to do 2 minutes of Cindy photos. So Wesley, you asked for Cindy. We will get some Cindy stuff. She's all kinds of a celebrity from all the places that she comes. Love this. Okay, so let's talk about storing your data, right? So if we have a database, it's going to sit on a server, right? And we have to store our information. So where do we store information in the cloud? Block storage, right? So our databases will be stored on block storage. So in AWS, the brand of block storage that they call it is Elastic Block Storage. They stick the word elastic in front of everything, and that's pretty much your test answer. Think about how you can shove elastic in many things. You probably know what to do. So when it comes to storing your database, we really have a couple options. We've got provisioned IOPS, which is what you're going to really use. And here's the reason you're going to use it. Even that is slow. So you want your database, you don't want to be waiting. Now, I can tell you who's people whose databases aren't good who are using the cloud. Ever go to a website and try and get some information like book a flight? And you notice things that used to be instant a few years ago now take like 30 seconds and your wheels spinning? That's because they're on the cloud and cloud storage is slow and they haven't figured out enough IOPS for their database. So you want the database to work, you need high performance storage, which means provisioned IOPS and maybe even RAID arrays of provisioned IOPS or post or FSX for Lustre if you really have high performance needs. The other option is general purpose SSD, which I wouldn't recommend unless you've got a low performance database or you don't need a lot. And if you really don't need a lot, like maybe my cat Cindy's website where she's selling some tuna, she can probably get away with low-cost magnetic storage because Cindy the cat doesn't have that many subscribers to her tuna-based website. She hasn't started it yet, but we've been talking about it. So let's talk about another kind of database in AWS. It's the Amazon Quantum Ledger database. And that is another fully managed serverless ledger database that's going to scale with the applications. Because it's serverless, guess what? You don't have to think about the servers. You don't have to provision. But again, Morton's Steakhouse versus McDonald's, it's all done for you. And when we're dealing with a quantum ledger database, unlike a traditional database with non-immutable record-keeping audit logs, like for example, like Amazon relational databases or DynamoDB, the quantum ledger database does not permit an add or an update or delete operations. So these quantum databases are really good if you're in an environment where you can't change the data. So think about that. Quantum ledger databases will track database changes by storing all changes inside of a transaction log known as a journal. The data that's going to be stored in the quantum ledger database journal is going to be immutable and cryptographically verifiable, meaning the data is there. It can't be altered, modified, or tampered with. And the quantum ledger database will track all changes made by the applications. Again, there's other versions of this. This is an AWS proprietary quantum ledger database, but it has a good purpose. It's an ideal when a repository of sequenced, accurate, and verifiable information is needed. Maybe you want to preserve some legal documentation about a vehicle ownership, like a title, for example, financial transactions for auditing purposes after the fact for an SEC investigation, fraud detection and analysis of records, maybe reporting employee payrolls. So now let's talk about optimizing your database. So we'll talk about backups, database snapshots, and encryptions. We'll also get into scalability in this section. We'll talk about read replicas. We'll talk about caching. We'll talk about queuing. We'll talk about high availability databases and the such. Let's talk about backups. Now, If you make your own custom database and you don't use any of the AWS managed databases, no big deal. You can just back it up the way you always have, and it's not a problem. But if you use an AWS managed database, it does do backing up automatically for you, which is pretty nice. And it backs up the entire database drive, which includes the operating system, all its dependencies. It includes all the data. It is an image. So the AWS managed automated backups are extraordinarily good. The cloud providers really took a lot of the backup work out of it for you. They are great. So the backup will occur during a defined window each day. Now, when these databases are being backed up, you got to copy information. So sometimes it locks down the hard drive for a short period of time. So while the database is being backed up, it may be temporarily unavailable. Or if it's not unavailable, its performance is going to be degraded. Well, you better know this, because let's say it's Black Friday and you're expecting, 1 million orders in 5 minutes, and your database is busy backing itself up. You're not getting any orders. So we'll talk about how to make that a little better, but just keep that on backing version. So what happens is the databases will create a database snapshot. And these snapshots can also be performed manually, which is good. And the snapshot is a point-in-time copy, the whole thing, the whole drive, and we keep it until we delete it. Why do I love this? This is really great. So let's look at it. You got your database, and it creates a beautiful snapshot of everything. So in a traditional environment, let's say you back up all your data and just the data in your database. Your database fails, here's what you do. You do the following. You take a Linux, you set up a virtual machine, you install the operating system, Linux or Windows. After that, you install the database, and then you load your data. Not here. It makes an identical bit-by-bit copy of what you have. So here's the thing. The database crashes, goes away, what have you. You take your backup, which is a single file. And from there, you just launch it. It becomes a brand new AWS EC2 instance running the identical software, having all the data. It's up and running like nothing. This is a beautiful system. The only thing to remember is before, my IP address may be one thing. And when I reinstall the database or create a new version of it from the image, it's going to get a new IP address, which also means it's going to get another DNS name from the domain name system. And by doing so, any applications that are pointing to the IP address of the old database will no longer work. You're going to have to take everything that was pointing to the old database, move it to the new database, and as they would say in Trinidad, Bob's your uncle. Everything works great, and poof, life is good. So kind of keep that in the back of your mind. And here's what it's really going to look like. You got your database snapshot image, you launch it, you get a brand new database with a new IP address. So now let's talk about encryption. Your database has some good information. What if somebody breaks into Amazon and steals the hard drives they have? Do you want that to get your access to your information? No, you encrypt it. The other reason you encrypt it is the information is stored as, say, gibberish, and without the decryption key, nobody can get it. Nobody can understand it. So you want to make sure that the hard drive is encrypted. Originally you had to use the key management system to encrypt the database. I'm pretty sure that Amazon in the last year made it standard encryption like every other cloud provider. Your drives are just encrypted. Now, Amazon also supports transparent data encryption, which is used on Oracle and Microsoft SQL databases. They've always done this. And they can also use transparent data encryption with the Cloud HSM, which is a hardware security module. There are other alternatives to the Cloud HSM module. It costs about $12,000 a year for the Cloud HSM module from Amazon. You can buy a good one for about $10,000 and use it for about 5 years. So $10,000 versus $60,000, the choice is yours. But again, it's a decision whether you want it fully managed for you and simple and elegant, or do you want to take the people to manage it yourselves? So those choices are yours. But understand you can do both. Here's the thing with transparent data encryption. When you send data to the database, it's encrypted as soon as it's stored. And it's decrypted when it's sent to you and asked to you. So it's on the fly, transparent data encryption, and it works with your two most biggest databases anyway, the two most industrialized one, the Oracle database and the MySQL server. Databases can also do encryption in transit. What does that mean? On the way to the database, you encrypt your data. And that basically uses the TLS protocol based upon SSL-based certificates. And effectively, you use a certificate that basically is used to authenticate the endpoints and encrypt your data, like you would do with a web page via HTTPS. So let's talk about scaling databases. Well, there's two ways you can do it. There's scaling up and there's scaling out. Let's talk about the difference. Scaling up is my database is on a server. It's got 32 cores. And my use is growing a lot. So I'm on a server with 32 cores. It has 64 gigs of RAM. And now I've moved it to a server that's got 256 physical cores or 512 virtual cores and 4 terabytes of RAM. Scaling up. I go from a little mini nothing server to a big bad server. But here's the reality. And the reality is this. Let's say even if you had a single server, it's a single point of failure. So that's one thing to remember. But no matter how many cores and how much DRAM and how much hard drive space that you actually use, what you're ultimately going to find is as follows. It's never going to be enough. You might need a whole bunch of servers with 256 cores, 4 terabytes of DRAM, 10 million IOPS RAID arrays on these things. So, you don't know what you need until you need there. So we can scale up by making bigger servers and scale out by adding additional servers. Because at some point, it won't be possible to scale up anymore. Now, the way we scale out databases is very differently. With the NoSQL database, we just take the database, we partition it, and chop it into little mini pieces. It's simple and elegant. And it's typically called partitioning. It may be called sharding, but the point is you chop the databases into many databases, and the database will have the intelligence to route to the right place. So that's something we're dealing with. We can also do the same thing with relational databases. We can partition them, but of all the database experts I've ever spoken to, they don't do it with relational databases. They only do it with NoSQL databases. So how do we scale out the database? Well, we do RAID replicas. So a RAID replica is a database that stores a complete read-only copy of the database. And MariaDB is not read-only, but the rest of them are read-only. And what you have is you have these RAID replicas that get synchronized in real time or very close to real time to the master database. And they provide additional load. So let's say right now I'm the master database. I'm writing information to me every time something occurs, and I'm answering you, which is via a read. Now, I want you to think about this. How many times can I answer questions and talk? So if you notice in the chat box of this presentation, you see some people that have blue rashes. Christopher Johnson, Alonzo Coleman, you see Chow Pham there. You may see Tyrone, who's a great cloud architect of ours living in South Africa. You may find Eddie Kem, who's in Bamenda, Cameroon right now. And they're all going to be answering your questions. Why are they answering your questions? Because I can't see your questions and present at the same time. Well, guess what? They're basically functioning as my RAID replicas. All I have to do is focus on them delivering the presentation, and they're there answering your questions in the chat box. So that's the point of a RAID replica, to take all the read load off of the server. And by doing so, if the read load is taken off of the server, then therefore, I don't have to answer reads just right. So it enables you to scale your systems. And, I don't really use Amazon graphics. I typically use more enterprise-y architecture graphics, which are usually blocks. But let's say you've got a 3-tier website. You've got your web server sending your information to an app server. It writes it to that M where it says main database. And then after that, it takes it to the RAID replicas, and the RAID replicas will handle these things. So when do you use RAID replica? when there's all this reading activity. So if you've got 4 times the read replica activity, the reads and the writes, you use 4 read replicas. When traffic going to the database to read it is slowing it down. If my cat Cindy has a database to sell tuna that she wants to go to, the read replicas themselves probably don't matter because she's not selling a lot of tuna. Now let's say Taylor Swift and Katy Perry, two big cat lovers, decide to tweet that say, go to Cindy's website and go buy tuna from cindy.com. Well, now all of a sudden we're going to have a lot of writes to the databases and a lot of orders. And the processing team is going to be running queries to see who to ship tuna to. Now, in this particular use case, we're going to have a lot of traffic, and we're going to direct the who do we ship the tuna to reads to the read replicas, and the main database is only doing writing. So that's there. So read replicas are not for high availability. Read replicas are for scaling performance, and that's it. So maybe I'm going to draw this out. I really want to help you guys, and I want to make sure that makes sense. So maybe we'll draw it out. I know it takes longer to go through the information, but I really want to know you understand it. So let's say we've got a database over here. We're going to call this the master, which is basically the head database. In a normal environment, we're sending requests to the database, and the requests are answering. Now, let's think about this. Every request to the database is going to hit the CPU, whether it's a read request or a write request. If we can get, so right now it's doing double the work. Now imagine we add some read replicas. I'm going to call it RR. And it doesn't mean route reflector. We're going to use it as read replica for simplicity's sake. And now all the writes go here, and all the queries are answered by here. So if you notice, the main database is doing half of the work, which means less work on the CPU, less work on the slow block storage in the cloud, less work on memory. Well, actually, the memory is probably about the same, but the CPU resources are going to be dragged down dramatically. Memory and DRAM will be slightly affected, but it's more DRAM. That's why we're dealing with this. So that's really what we're talking about. Now, if the read replicas take read information off of the database, let's talk about caching. So if we're in an environment where information is different every time, so let's say I'm trying to find information on tuna for cats, and the next person decides to look at how to get shrimp for cats. The next person is looking about how to get scallops for cats. Each time the database will have to respond. Now, let's say Cindy has a brand new, I don't know, Cindy made some cat clothes, like a cat necklace, and all the cats want the cat necklace. And every cat from all over the world, cats in China, cats in India, cats in Africa, cats in Greece, cats in the US, all go to the internet. My cat does it all the time by walking on my keyboard, and they all want to see shrimp for cats, and it's the same website. Well, then the cache will take over and answer it after the first time. So caching is going to make things speed up, and it's going to reduce the load on the read replicas if the information is the same. If the information is different, meaning different, the cache will actually slow it down. So kind of keep that in the back of your mind. That's when we use caching, when it's frequently used. So keep that in the back of your mind. We're going to talk much more about caching when we get to content delivery networks and the such, but keep it in the back of your mind. Now, when it comes to caching, you've got options. You can run the same cache on every single cloud provider by getting a virtual machine with large amounts of DRAM and setting up setting up a Redis cache. Now, you've got the same cache on every cloud, no proprietary anything. Now, if you don't want to think about it, guess what? You can use the fully managed cache. And AWS offers you 2 versions of a fully managed cache. You can use a Redis cache, which is a very high performance, high functional cache, or you can use memcached, which is typically a simple, basic Everett environment. And we'll take it from there. And actually, I'm going to address one question in the chat box. I'm not a database architect, but you can be an architect without building it, because a doctor does not need to have a heart attack to know how to treat a patient with a heart attack. They don't. And a doctor doesn't need to be a drug addict to deal with a drug addict patient. There's a difference between education, which prepares you for real life and real world, and assuming that you can just learn how to do somebody else's job and know how to design. And I agree that no one can be an expert in anything. My expertise is designing high availability, high security network and cloud architectures. Databases are not my world. I deal with database experts. But the point is, a database architect does not need to be a database engineer. They can learn how to be a great architect. And that's why there's lots of chief information officers and chief technology officers that don't come from a tech background, and some of them are great. The key is you have to learn it. Nobody's born a doctor. Nobody's born a pharmacist. Nobody's born an airplane pilot. They get education. And that's why anybody is welcome from all over around the world to be able to build any great career. And you don't need to start at the bottom. You don't need to learn anybody else's job. You need to get the right training. All of you can be amazing. So think about that. The next time someone says, if you haven't mowed a lawn, you're not going to know how to design a hotel. Or if you haven't built a hotel, you're not going to know how to build a hotel. That's why construction workers don't build hotels. Architects design hotels and construction workers build them. Keep that in the back of your mind. That's why people do not hire flight attendants to fly the airplane or nurses to be doctor. I don't claim to be an expert on anything. I am not a database expert. I am here providing free training for the people that need it in this world, because what I've done in databases for the last 25 years is more than most of the people that are charging for their several $1,000 boot camps. I'm not a database architect. I don't pretend to be. If you look at me, you can see what I've done, which is cloud, network, and enterprise architectures for the world's largest business. And that's it, not databases. I bring in a big data architect for every architecture. I bring in a data scientist for every architecture. And I bring in a database architect too. That's why people hire an architect like me. And architecture, as I mentioned to you yesterday, it's a team sport. You've got a leader that brings in all the best experts, and that's how you design it. And I'm a good friend with Praveen. And that's why I brought him in to talk about data lakes, and you can see videos from it, because I wouldn't pretend to be. So let's get back to the content. But I don't want anybody thinking they have to do somebody else's job to learn how to do their job. That's totally not true by any stretch of the imagination. So caching will help, like it will on a website, if the information is the same. And caching works by offloading read requests from the database, from either the main database or the read replicas. And by doing so, it lowers CPU, DRAM, and disk I/O requirements. So you want to use a cache if they're frequent requests for the same thing. For the same thing. So what would a cache look like? Cache would look like this. You put your information from your 3-tier website, you attach the web server, you go to the app server, and then you hit the cache on the website. So when people are going to Cindy.com to look at salmon, they are both going to be information. It's going to hit the web server, the app server, and maybe it doesn't have to hit the database, the cache answers. There you go. Now, we'll talk about queuing, which is really important, and we'll talk about why. So for those of you that are in Jamaica, those of you that are in England, those of you that are in Nigeria, and any place that speak traditional British English, you know what a queue is. You form a line. Well, when I learned about queuing 25 years ago, and it was in networking, I'm like, what the heck is this queuing concept? The point of queuing is it's a need to schedule the delivery of your stuff or your messages or your packets. And here's the thing. You want to make sure that every packet makes it to the database on time. So I want you to consider this. Let's say I've got a database and it can write 1,000 messages a second. Now, my database can write 1,000 messages a second, And that's after getting rid of offloading all these stuff to the read replicas for all the read. And now, out of nowhere, all these incredible social media stars tweet. They post to Instagram, TikTok, Facebook, YouTube, and go there. And it all says, buy Cindy's stuff. And all around the world, we got people trying to place orders. We can handle 1,000, and we've got 10,000 orders in 1 second. Do you know what? But the database can only handle 1,000. Do you know what happens to the other 9,000? They're lost, gone. Business loses money. Does anybody think that's a good idea? No. So here's what we can do. We can find a way to schedule. We can use a queuing system. And all the queue is intermediary steps. So we can take the messages get sent into the queue. And they sit in the queue until we're ready to get the information. And when they get taken out of the information, they're removed from the queue. So why do we do this? We do it because it enables us to schedule the information, reduce CPU overhead on our system. So let's look at what it would look like traditionally. In an environment with a normal database, here's what you're going to see. You're going to see people, you're going to bursts of things. The CPU could hit 100%, you could drop stuff, and then a second later it's slow and the CPU is at 3%. And you can see on the chart on the left that we drew for you, you can see the CPU spiking on that database. But by using a queue, we can smooth out the peaks and the valleys so that at all times the information is sent to those who need it. So instead of the CPU reaching 80 and then going down to 20, maybe we can smooth it out to 40%. That's the whole point, to not lose messaging. So now that it comes to queuing, okay, now we find ourselves in the same position. If we are in a multi-cloud environment, we want to use a multi-cloud queue. Let's think Apache Kafka. You put it on a virtual machine, you put the same Apache Kafka queue in Google, Azure, and AWS, and Bob's your uncle. Life is smooth. But if you wanted to use a proprietary managed queue, so you don't have to do that, and your business is only going to be on AWS, they have a beautiful fully managed queuing service called Simple Queue Service. And realistically speaking, we could use that instead of creating our own, but now we're locked into a single cloud. So take that for what, make those architectural decisions. What are the business requirements? What are the availability requirements in the system? How much does downtime cost? In case you didn't know, for 44% of a business's 1 minute of downtime is worth over $1 million. So think about that. For those businesses, I know businesses that lose $1 million a second. I've worked on them. They can't go single cloud. I know other businesses that doesn't matter. So you just think about it. It's based on what you're used to and what you're working on. Now, when the messages come in the queue, there's two ways they can come out. They can come in and they can come out as fast as possible. And that's going to be the default for the Simple Queue Service, or SQS, in and out as fast as possible. Or they can be sent in the order they are received. First message in, first message out. Second message in, second message out. Third message in, third message out. Fourth message in, fourth message out. And if you do that, it'll slow it down. Because sometimes the first message could be 1,500 bytes and the second message could be 60 bytes. So we have to think about what that means, what we're using, and kind of convince that. So keep that in the back of your mind. So it's going to help messages from being lost. It's going to reduce write contention, which is going to enable your systems to scale. If the database went down for a couple minutes, but the messages are stuck in the queue, you don't lose anything. So you want to use a queue when you want to increase scalability because of a lot of write loads into the system. Right. So read replicas, read. Caching, read. Queuing, write. So that's how we're smoothing out read and write loads to make the system scale. When you are not sure how much performance is needed, put a queue in, and that way you don't lose anything. So kind of think that in the back. And if you need extra assurance you don't lose critical messages, put a queue in. How often do you think businesses can afford to lose orders? Put a queue in. What's also cool is not only can the queue especially SQS, be used to reduce contention. Not only will it keep messages from being lost, not only will it improve scalability, but we can actually use queuing in certain circumstances and the message depth to determine if we need more servers and to facilitate auto-scaling. We can't auto-scale a database, but we can use it for other things. Now, let's talk about extraction, translation, and loading. There are a million tools that you can use to get your data from one database to another database. There are industrial tools that are great. In a multi-cloud environment, use an industrial tool to get your information from one database to another. In a single cloud solution, if you don't feel like using an industrial product, you can use Amazon Glue, which is the Amazon branded extraction, translation, and loading tool. And we can use this very well to take information from one database to another. Remember, each database has its strengths and weaknesses. And in business, we might need them all. Relational databases, data warehouses, NoSQL databases, data lakes, so we can gather the right information to make the right decisions. Now let's think about it with AI. Now we need even better information and more input for us to train our models to be able to do these things. So Amazon Glue is a fully managed ETL service, meaning you don't have to think of servers and things like that. And it's a matter of just pointing the Glue to where the data is stored, and it's going to massage the data for you. Glue will discover the data, store the metadata in a catalog, and then make it searchable and queryable. And then the data can be loaded into anything like a data warehouse. You know, here's an example of how this would work. You got it in object storage or S3. You can get your information, and it can crawl your information, and it can take your information from everything and put it into wherever it needs to go. Now, somebody asked earlier, how do you get your information from the database to the cloud? Well, as I mentioned before, if it's an Oracle virtual machine, you can just take the virtual machine you have, move that virtual machine over to the cloud, poof, it's done, without any of this stuff or thinking. And that'll work across all clouds. By comparison, if you wanted to take your data out of the Oracle database and stick it into, say, Amazon Aurora, you're going to have to get the information out and massage it. And Amazon has this thing called the schema conversion tool, which is a managed service that's going to simplify getting your information from one database to another. Now, I want you to understand synchronization and conversion. Posi sa oli sa daxi samara? Now, I spoke to you in Greek. Now, if I said, I'm going to change your lights in Greek, that's a huge insult. It means I'm going to fight you and beat you up, which I would never do. I love people. But that's what they say in Greece. Now, if I take my American friend Chris or Alonzo and I say I'm going to change your lights, they're going to think I'm going to come to their house and change their light bulbs, because some things don't translate across languages. Understand, when you use a schema conversion tool or any tool to get information from one thing to another, it's like you took Punjabi, translated it into Hindi, and then translated it into Farsi, and then translated it into Arabic, and then into Hebrew, and then back to English. You might lose something along the way. So keep that in the back of your mind. Whenever you're translating data, somebody that understands databases is going to have to normalize this and check it. But with the schema conversion tool, when you're migrating to a database, the schema of the source database is going to be converted into the format that's going to be compatible with your target database. Does it sort of automatically for you. And the AWS schema conversion tool will give you a graphical interface to automatically do these things. So helps you with migrations and things like that. So how much more do I have in databases? What I'm going to do is this. I'm going to finish the database. Then we're going to spend maybe 15 minutes answering questions. And then we'll get into some fun networking stuff, which is my part of the world. So according to Amazon, how do you do a high availability database? Well, according to Amazon, you stick it in 2 availability zones in their same cloud. And when the cloud fails, you're a host. You could do multi-cloud, multi-availability zone, but the point of the certification, we're going to say multi-availability zone or multi-data center. In the single cloud is high availability. For practicality purposes, I think you may need to think otherwise, but that's up to you. It's up to your clients and their business needs. That drives it, nothing else. As a reminder, AWS divides their network into regions, those large geographic areas, and those availability zones as little data centers inside of them. Keep that in the back of your mind. And what can happen is we can put our database in a primary data center and a backup data center. And what happens is the database copies all the information synchronously to the second database. And if the primary database were to fail in availability zone data center A, the backup data center 1 will take over. So there you go. We can keep those kind of things. So how does it work? It works very simply. You've got your database here. You've got your basic 3-tier architecture, your web, your app, your database servers. You got your primary database that's up and running in the main data center, and the backup, which is just sitting around waiting to be used if things fail. So you've got it set up, main database, data center, or availability zone, second backup availability zone and data center. What will cause it to fail over? Well, if your primary database fails, poof, switches over to the backup. How about if the availability zone or data center has an outage? Theoretically, it'll switch over to the other one. If you change the instance service type, it'll move over. If you take your database under maintenance, maybe you want to patch it or upgrade it, it'll switch over to the backup. Or you can manually say, go to the other one with a reboot with failover. So at this point, we're going to take some questions. There's probably a ton of them that are in there. And I want to make sure you all get a great educational experience. I hope you are. So the read replicas themselves aren't cached, but the data is the same. So Chris, let's talk about the difference between a cache. A cache is I store frequently accessed information in memory so that it doesn't have to be sent to the read replica. The read replicas themselves don't have a cache inside them. We'd have to add a cache on top of it. Good question, Chris. Would you recommend Docker or Kubernetes to learn for the SAA? Fernan, I recommend that you learn what's appropriate for the job, and every single role is different. In almost all roles, an architect will need to understand Kubernetes, at least how it is architected. Where is the control plane and where is the data plane? The new versions of Kubernetes work without Docker, but in the old days, what we had is we had container orchestration, which was done via Kubernetes, and we had container runtime modules, which were done with Docker. In some cases, it's still there. I would recommend that you learn whatever is appropriate for your career, Robert, and I don't know which career you want. For example, a cloud architect needs business skills, sales skills, executive presence, emotional intelligence, leadership. They need network and data center design skills. They need the ability to build a business case. They need the ability to do a lot of things. But an architect will never touch the technology. We're not allowed. By comparison, a cloud engineer will need to know Python. They'll need to know Linux. They'll need to know Terraform. They need to be very familiar with the command lines. They're going to be very deep on Kubernetes and very deep on Docker. They're going to be deep on shell scripting. But you can see two different jobs have an incredibly different set of skills. So Robert, I don't know what job you want, but you come tomorrow on the How to Get Your First Cloud Architect Job webinar, and we'll go over the architect job if you want. And tonight, feel free to pop in. At the session tonight, it's going to be on Zoom. You can ask a question and I'll answer it face-to-face, but I do want you to go to that How to Get Your First Cloud Architect Job webinar. It'll really change how you think about everything, and we will cover the entire list of everything you need to know. Good question, Fernan. I'm glad you asked. FB, do we find what data request should hit? No, nor did the cache manually start. So the cache, we set it up, and if it's been accessed before, the cache will answer. If it's not been accessed before, the cache will not. How do you convince a large organization to go to the cloud? Dragonfly, your goal should not be to convince a large organization to go to the cloud. Your goal should be, how do we improve that business as much as possible? And come tonight and we'll discuss that in depth. Sometimes the best thing for you to do is keep them off of the cloud and build a private cloud. Sometimes the best thing for you to do is to build a hybrid cloud. Sometimes the best thing for you to do is to build a hybrid multi-cloud. Sometimes it's multi-cloud and sometimes it's single cloud. I don't want to ever force anybody to go to any technology. That's what's called being an evangelist. Here, you need this. Everybody needs an iPhone. Everybody needs an iPhone, everybody. The iPhone's the best phone. Why don't you get an iPhone? That's what somebody does when they're an evangelist and they try to convince an organization to go to the cloud. Now, if we evaluate their information, their knowledge, and then we understand what their business case is, what their workflow is, how the information is going to be utilized, and how they want the business to operate in the future, then we understand their business needs, and then we can suggest the right architecture for them. And then it's a matter of building a business case, meaning showing the client that the $100 million they spend a year on the cloud is going to be paid for because they're going to do $200 million of additional sales or save $200 million in employee costs or something. So come on tonight and we can discuss that. I love discussing sales. Sales is the most critical skill for your career. If you have two sources for data, can load balancers distribute? Now, this is not, Chris, load balancers, and we'll get into them. Load balancers are designed to load share across things, but not databases. Good question. How do we establish that queuing is affecting write load? Well, you can check and see if there's any messages in the queue. If there's no messages in the queue, then basically we don't have to worry about it. If you've got two sources for data, sync and load balancers distribute queued messages. No, databases do not use load balancers. Because not all databases, so good question, but I want you to think about that a little more, Chris. Now, if we're using Oracle, we can write to two databases at the same time. But the rest of the databases, or if we're using Apache Cassandra, we can write to most databases. But the reason we're getting involved in all this networking gear is, so the reason we're getting involved in all these databases and things is we have to do replicas and caching is to reduce the write load because most databases can't write to more than one node at the same time. Confirming that the route reflector can be used with no SQL. Oh, a read replica. Read replicas are not used with no SQL databases, Brian. Only relational databases. Good question, Brian. Is the CCNA a good plan to have a solid networking background? The CCIE is what I would consider to be an intro to networking. I will tell you that I actually did the CCIE when it was a challenging exam back when it was a hard 2-day exam. And I will tell you that it took me 6 months to pass the CCIE from the time I started studying it. And it took me 25 years to actually become an expert in networking and learn networking thereafter. So, you know, the networking knowledge that people need is somewhere between the CCNP and the CCIE to be a cloud architect. For us, when we teach in our cloud architect program, it's nothing. But the CCNA is a good start. It's a very good intro first level networking, but you need more than that. The CCNA doesn't cover BGP. It doesn't have any depth of OSPF or other routing protocols. It doesn't get any depth into route aggregation or traffic engineering or any of the things we need to, but it's a good start. I would definitely start. In fact, I like it so much as a start, I put a free CCNA bootcamp on our channel. Great question. And I would do that, but networking is the most fun thing in the world. I encourage you to learn it. And since the cloud is just somebody else's network in a data center, it really helps out so much. Any others, Chris, or is it back to the content? Okay, yeah, I remember, Chris. Okay, well, what do I think of COBIT 2019? Augustine, I like frameworks. They're good. That help you look at things. You know, one day I'm going to do a video on the difference between the AWS well-architected framework and TOGAF. There are frameworks that I really love. There's the Zachman framework, which I tend to like, and there's the TOGAF framework. Go Cloud Careers is a member of the Open Group, which is the TOGAF framework, and here's the reason I use it. While other frameworks focus on the technology, the TOGAF framework focuses on digital transformation, meaning improving the business with technology. So TOGAF basically encourages people to start with the executives first. Straight from the CEO, CFO, COO, how's your business now? Where do you want your business to be in the future? And then it's all about mapping out the business processes and how the business operates today and determining how we want the business to operate in the future. From there, it's a matter of thinking about how the data is today and how we want the data to be in the future. And from there, then it's looking, what is the technology today? And then what do? We say, if this is how the company wants the business to operate in the future, and these are the business requirements, we work backwards and we figure out the technology we need. Meaning, what levels of servers, what levels of storage, what kind of security, etc. for everything else. And only after that do we actually think about products. So I absolutely love the TOGAF framework. We're a member of it because everybody is, whether it be Amazon, whether it be IBM, whether it would have been Cisco, it's everywhere. And pretty much every major organization in the world leverages TOGAF and the way they do things. So at Go Cloud Careers, we're members of the TOGAF. We pay to be members there. And we participate with it because it's our favorite framework for digital transformation. And as far as RJ's next question, what's a good source to get fundamental data center information? Well, we teach it heavily in our Cloud Architect Career Development Program, but there are other people that actually also do this. There used to be a Cisco CCIE data center, which they really talked about servers and storage and load balancers, and it was really great, and routers and switches and things like that. But that actually did a good job. We covered extensively in our Cloud Architect program, because if you don't know the data center, you don't know the cloud, because you got to know those underlying technologies. And if you're not with us, you can learn things like, you can learn about servers from, say, Dell, IBM, Lenovo. You can learn about storage area networks from, say, EMC and IBM. You can learn about load balancers from F5. They've been making them for 20 plus years. You can learn some security information from Checkpoint, Palo Alto, Cisco, Fortinet, for example. And you can go to the vendors themselves that are experts in these environments, but they're still not going to teach you how to put the parts together. And that's why we do what we do. They're basically name, configure. So it's tough. I wish it wasn't that. And that's why we do what we do, because I don't want people to have to spend what I had to spend to do this. I mean, I just don't want anybody to have to deal with that. And as far as Wesley, how much, Wesley, we'll go to Wesley's and then we'll go back to the content. So comparing the cloud practitioner versus the SAA, how much harder is the SAM? It's not harder, Wesley. So here's the thing. You can make any exam challenging regardless of the content. I mean, I could make a 300 question hard exam on cat paws if I really wanted to. Well, we could talk about the structure of the nails and this and how complicated it is. We could make it challenging and ask the questions in a ridiculous manner. So no matter which one of these exams are, the level of difficulty is about the same. It's just what you need to know. Now, what do you need to know? I'll give you a hint. When you actually look at a cloud practitioner, the first thing they start out is billing. So, they're not really focusing on making you a cloud computing expert. It's just like an intro to an intro to an intro to an intro to an intro. I tell everybody to skip the cloud practitioner, go straight to the solution architect, and then go straight to the professional, be done with your AWS certs, and to do something else. Good question, though. Chris, what time is the additional questions tonight? See, everybody's got to have a read replica. 5 p.m. So at 5 p.m. tonight is the next questions. Okay, now let's get into some basic networking, which is my favorite thing in the world. Understand that it was 75,000 pages of reading to pass. Well, actually, before we do this, give me a hashtag that I know that you're awake. Give me the hashtag, in this case, hashtag AWS Certified Solution Architect Associate. I know that's going to make me really know if you're awake. I want to take a CAT exam too, Wesley. So a hashtag AWS Certified Solution Architect Associate. That way, We know you're here. And boy, this fly is getting on my nerves. I leave the door open for my cat to come in and out a lot, and she keeps bringing in flies. So she'll catch it in a few minutes. Here we go, Leo. Manoj, I like to see that. Ciao, Alonzo. Notice the blue wrenches. Great read replicas over there. Richard LaPasco. Always good seeing you. Mr. Gee, haven't seen you in a while. Come back. We'll be thrilled to see you. All you guys are doing great out there. So it seems to me you're all awake. You're all alert. You're all oriented, and we're having fun. So let's talk networking, which is my favorite thing in the world. So when we begin with networking, we really have to have a common level of understanding and communication. So I come from a world in medicine, and in medicine, we use very simple, pristine language, and we do so to avoid errors. Communication errors cause bad things to happen. In medicine, communication errors cause death. In networking and data and cloud, communication errors cause outages. So we want to be very precision in the way we communicate, which is why you'll never call me here a virtual machine, an EC2 instance, or a Google Compute Engine instance. You'll call it a virtual machine, because every chief information officer and every customer I ever have will understand me. We're speaking a common language. Now, the same thing occurs in networking. So with networking, we use a terminology called the Open Systems Interconnect model to explain all levels of the network. Now, I'm going to explain this to you so that you understand it. And every networking person you deal with, whether they're in Spain, whether they're in Trinidad, if they're in Jamaica, if they're in South Africa, if they're at my vacation home in Greece where my family's from, if they are in England, and if they are in Palm Beach, Florida, it'll all be the same. Therefore, you're going to be great. So we've come up with 7 layers of this model. And we're going to divide them up into 7 layers. And I want you guys to understand what these layers actually are. The physical layer, or layer 1. Chris, can we remove that thing that's up on the slide? So the physical layer, which is hidden by the call out on the slide, refers to the wire. This is called layer 1. And for networking people, we always talk about layer 1. This is typically what help desk typically deals with too. You call help desk and you say you can't print, and they say, is your computer plugged in? Is the printer plugged in? Is your computer plugged into the network? So this is the Open Systems Interconnect, or the OSI model. Layer 1 is physical. Please remove where it says RJ on the screen so the rest of the people can see the slides. RJ, we're really happy for your appreciation, by the way. Okay, we're running into a technology problem with software as a service. It's not ours. Okay, so layer 1 is the wire. And what do we send on the wire? We send bits. How do we send bits? If it's a physical wire, like a Cat5 or Cat6 cable, we send electrons down the wire. If it's a fiber optic connection, we're sending light or photons down the wire. So layer 1 is physical wire. Now, the next layer that we networking people talk about is the data link layer. That is the layer 2. Now, we're talking about a hardware address. So if any of you have a notebook computer, a server, you may notice that it's got an Ethernet port on it. That card, or that piece of hardware, is layer 2. It's the MAC address. And what do switches send out of those MAC addresses? They are called frames. Layer 1 is the wire. Layer 2 is the card level, or the hardware. Now, layer 3 is the network layer. This is logically addressed and via logic. So an IP address is a network layer protocol. An IPv4 address, an IPv6 address. In the old days, AppleTalk addresses, IPS addresses, all layer 3 addresses. So layer 1, physical cable. Layer 2, card or physical hardware. Layer 3, logical address. Now, layer 4 is the transport, which determines how do we send the data. Do we send it via TCP? Do we send it via UDP? Do we send it via the ICMP, Internet Control Message Protocol? If you don't know what those things are, I discuss them in depth in the completely free CCNA Bootcamp, which you can see on our YouTube channel. Now, for networking people like me, we all stop at layer 4. Layer 1 is the wire, layer 2 is the card, layer 3 is the IP address, and layer 4 is TCP UDP. Now, once we get above this, we networking architects like me check out and other people get involved. At layer 5, we really have what's called the session layer, and this is side of managing the connection. Now, layer 6, actually network people like me do get involved because typically here's where your encryption is. So encryption that we might be using, we will have at layer 6. And layer 7 is the actual application you use, like the web browser that you use. That's layer 7. So layer 1, physical layer. Layer 2, data link or card. Layer 3, logical address, such as an IP address. Layer 4, transport. Do we need reliable transport and we use TCP? Do we need real-time transport and we use UDP? Do we need to ping something or do a trace route and see what's going on networking-wise? It could be an ICMP message. Above that, we've got session, which controls the connection, typically at the socket level. Layer 6 is presentation to the upper layers, and we're dealing with encryption at that layer. And layer 7 is the application, which is what you use. So let's talk a little bit about IP addressing. I can't cover IP addressing in a one-week boot camp. The CCIs like me that design the IP address plan for an enterprise learned IP addressing in, say, 6 to 12 months of doing it all day, every day, and sometimes 5 to 10 years. So it's not something that's really good. Now, the reason I'm talking so deep about IP addressing is like planning the roads in the city. Do it right, everything's beautiful. Do it wrong, and everything falls apart. So if you are not a network architect, I recommend you get a network architect to help you with your IP addressing. So let's talk about an IP address. What is it? It's an address that you give your digital devices, whether you be your mobile phone, there's a little photo of my cat on there, by the way, or whether it be your notebook computer, whether it be a server, it needs an address. Now, we all have houses. We all get mail, right? It's usually junk mail or bills or people trying to sell us something, but we all get mail delivered to our house. All of us have a unique address. We could have a 123 Main Street, but the city might be different. Or we could have a 123 Main Street in the same city with 2 different zip codes. But every house address needs to be unique in order for you to get your mail. Keep that in the back of your mind. It needs to be the same. So your computer will need a unique address. Now, for the intranet to work, meaning inside of your network, inside of your organization, every device will need a unique address. But internally, you're going to use private addressing. Externally on the internet, every device needs a unique address as well. So keep that in the back of your mind. Now, there's really kind of 2 versions of internet protocol. There's IPv4, which is pretty much everything that we're using today still. And there's IPv6, which has been around for decades, that pretty much are used for mobile phones. So let's talk about IP addressing for your VPC. Inside of your VPC, you are going to use private addresses. If you want to learn about private addresses, I recommend you go to the Internet Engineering Task Force page and read RFC, Request for Comments, which is the specification, 1918. And in that, they specify these CIDR ranges to be used for internally organizations. They recommend the 10.0.0/8 address space, that's a class A. They recommend the 172.16.0.0 all the way to 172.31.0.0/16. And they recommend the 192.168.0.0/16. These are private addresses. They're used inside of your organization. They are not globally routable. So let's talk about IP address classes. We used to have this content, we used to have these IP address classes that are there for, that were there. And they were the 1 to 126 range. that were class A's. They were the 128 to 199, 191.255.255.255.255, which was a /16. We had our class C's, which were the 192.0.0 all the way to 223.255.255.255. And we have the class D addresses, which are IP multicast. 1 second, guys. Now, a long time ago, when you were networking, you used to have to type IP classless on a router to tell it to go classless. But for the last, say, 20 years, we've always been using classless IP addresses. And what does that mean? It means we don't have class A, class B, class C, or D anymore, or class A, B, or C. We just sub them down. Class D is, for the most part, what we're dealing with. So because we're not going to use these classless addresses, and why don't we want to use a classless address anymore? Let's talk about this. If every device on your network needs to be on a different subnet, every device. So I want you to understand this. Why are we subnetting? Let me draw it out for you. So let's say we had a little mini router here. And this would be more like a home router, but let's just say the router had 4 interfaces on it. That looks pretty ugly. I'm going to draw a prettier line. So let's say we've got a router with 4 interfaces. Each one of these has to be on a different network. Okay? So if we use the class A address, like 10.0.0.0/8, and we put an address from that block, like this, on this address, now we need to be on a different subnet. Now here's the problem. With that 10/8, we have 2 to the 24th minus 2 addresses. So we'd be wasting millions of addresses on this interface. And if we now put this over here, oops, hold on, bear with me. And now if we took this subnet over here, and this subnet had 2 to the 24th power minus 2 addresses that we'd be using on this subnet. And then on this subnet, we took another class A, and this would give us another class A. And then we've got another one that we put over here as a class A. On each subnet, we would be burning 2 to the 24th power of IP addresses, minus 2 addresses. So, but think 2 to the 24th. Now, I don't know about you, but in a world where we don't have a lot of IP addresses, we've got to conserve them. So by comparison, if we took this one block and we had 10.0.0.1, and we made this a /30, and then we made this 10.0.0.1.5/30, and then we had this as, I know it's a little geeky here, but I have a free workshop you can watch for this as well. And then you had this one as 9, and then you had this one over here as 13. What we would be using is 16 addresses instead of 2 to the 24th times 3 or times 4. So the point of doing this is we're trying to conserve addresses. And for the people that want to know how much level of subnetting they need to know, a lot more than I just covered. But we have a free webinar for you to do that, and we teach this heavily to our students internally. But understand, that's what we're dealing with. So what we're really doing, good idea. What we're really doing is we're taking our network and we're chopping it down so we conserve IP addresses. And you know what? Do you guys all want a subnetting workshop? You want me to do another subnetting workshop? If you do, I'll create a 4-hour subnetting workshop. Me and my team will teach it to you. Give me a hashtag subnetting. And if you guys want a hashtag subnetting, Chris will probably also run a poll. My team will run a poll. And enough of you guys want me to do a subnetting workshop, I'll dedicate the time to do it. I love helping others that are out there. And really, that's all we're talking about. By doing subnetting, we're taking a big block and breaking it down into a little block. And when I say architecture is not technical, I don't mean that you don't have to have deep technical knowledge. I say we don't touch it. We have to understand, what is the tech? How does the tech work? How does the tech work together? We've got to get much more technical on the why. We just don't do the how. Just keep that in the back of your mind. So we'll do some subnetting, and maybe my cat Cindy will help me along the way. Now, subnetting is how you take a big block of IP address, a big CIDR block, and chop it down into little things. Supernetting is the exact opposite. So we may also need to take certain routes and certain subnets and aggregate them or summarize them. Why? Well, if I'm dealing with a regular Cisco router that can take 800,000 routes from 10 different internet service providers, no big deal to me. None. But, you know, when we're dealing with a cloud provider and we can send them 100 routes or 1,000 routes, we have to do the summarization. Otherwise, there'll be too many routes because of their limitations. So we kind of keep that in the back of your mind. Route summarization is the exact opposite of subnetting. So here I've got a direct connection or a VPN to my router. You can see what I did here is I took 192.168.0.0/24, 192.168.1.0/24, 192.168.2.0.24, and 192.168.3.24, put them together into a 192.168.0.0/22. And by doing so, I only need to send one route. Now, I can't teach this in today, but if you guys, enough of you guys, I think, asked for it in the poll, I think we can do a subnetting workshop for you. My team will set it up. Now, we can also use IPv6 addresses too. IPv6s are a newer form of IP addressing, and by newer, I say 25, 30 years old. Nothing's new. And instead of having a 32-bit binary address, we now have a 120-bit hexadecimal address. So with IPv4, we have 2 to the 32nd power minus 2. You can do 2 exponent 2 in your calculator, subtract 2, and poof, you got your answer. Now that's because binary is 0 and 1, and that's why it's 2 to the 32nd power. Now with hexadecimal, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Alpha, Bravo, Charlie, Delta, Echo, Foxtrot. So we actually have 0 to 16. So now we have 16 to the 128th power. Now you can think of those IP addresses. Now we're talking scalability. But for the most part, IPv6 is barely even used. We're going to adopt it pretty soon because we were out of addresses and everything has been, you know, getting an IP address for the last couple of years. And I'm pretty sure it's going to happen. And it's going to happen, well, soon might be the next decade or so. Technology moves very slowly, even though people think it's actually fast. It moves very, very slowly. Ooh. So that was a little bit of basics. Now let's get into the VPC. So when we're in the VPC, we've got to think about the components. The VPC is your virtual private data center. So what do you think in the data center we're going to be dealing with? We're going to be dealing with routing, meaning routers. We're going to be dealing with connecting to the internet. So think internet-facing routers called internet gateways. We might want to create an environment where we can go out to the internet to update our systems, but not be reachable from the internet. Guess what? We've got what's called NAT gateways, which we'll talk about for that. We'll then talk about IP addresses a little bit. We'll talk about the creation of endpoints. We'll talk about getting 2 virtual private data centers to talk to each other. We'll talk about packet filtering, and we'll talk about host-based firewalls for some of these systems in the VPC section today. So the first thing we need to talk about is the routing table. Routers will build a routing table, which tells them how to reach things. So, what does this kind of look like? It's going to look like this. Because let's say you've got a router. I'm going to map it out for you. We'll just whiteboard. Let me just fix this. I cut and pasted some funny business into a PowerPoint slide. So realistically speaking, routing is pretty simple. Let's say you've got a router over here. This generic symbol for a router is a circle. So here's our router. The router has two interfaces in it, or a couple interfaces in it. We've got one interface up top. We've got another interface on the bottom. We've got another interface over here. And we've got another interface here. So let's say over here, we've got this subnet. We now have a switch. And over here, we've got some servers. And this is what you would see inside the cloud provider. Most of my life has been more spent designing the clouds. And these are, say, a server. And let's put another router over here to prove the point. So let's say this server over here is 192.168.1.3. This router over here is the 192.168.1.1 IP address. This link over here is 172.16.1.1 and 2 on both sides of the link. And then you're over here on this router. Now, let's say you've got a user that's attached to this router. Here's a PC. This is going to be very similar to what you have when you want to reach anything. Your PC is connected to a switch, which is then connected to a router. And let's say you want to get something off of the server 192.168.1.3. So the PC, which you could barely see over here, let me try and just deal with this for a second. So the PC, which you could barely see, is now wanting to reach 192.168.1.3. So the PC is going to look at its routing table, and this is going to say, do I have a route to 192.168.1.3? Your PC will not, but your PC will most likely have what's called a default gateway, which is, if you don't know where to go, send your data to the router. So now your message makes it to this router, which is over here. Your packet's over here. Now the packet's destination address is 192.168.1.3. So the router looks in its routing table and says, do I have a route to 192.168.1.3? And it has a route in its routing table. And it says, yes, I do. Go out this interface. Now the packet is on this router, and the router says, do I have any idea how to get my data to 192.168.1.3? And it does an ARP request, which says who has the MAC address for 192.168.1.3. And it then sends it to the switch, and then it sends it to this router, or to the server. The server now responds, and the server looks in its IP address, and it looks in its routing table, and it says, do I have a route to the PC? And of course, it doesn't, but it's got a default gateway. So this server sends its information to the router. The router looks in its routing table and says, do I have the MAC address for this PC? And do I have the route for this? And it says, I do. Go out this interface. It hits this router, and the router says, sure, I do, and it sends the message back. So the way we're actually talking about is as follows. Routers build a table, which is a map that tells them where to go. So now you actually understand what we're actually talking about when we're dealing with the router and the router itself. Let me bring this over a little bit so that we're more where we need to be next time. So that's kind of what we're dealing with, and that's how routers build a routing table. So when you have a VPC, guess what? The VPC builds a routing table via a virtual router that says, here's how you track your traffic to the internet, here's how you get here, here's how you get here. Now, the other thing I thought I would show you before we go is when we deal with routing, there's really two kinds of routing that we deal with. we're either dealing with internal routing or external routing. Internal routing, we run what's called an interior gateway protocol, and this is your traditional enterprise network or cloud, where inside of our organization, we use an interior gateway protocol like open shortest path first routing protocol. And then externally, we use BGP to connect. So what you'll typically see is you'll see the cloud provider, let's say they're on the right, they're going to have their routers and they're going to be running one of two routing protocols, OSPF, like we have here, or something called intermediate systems to intermediate systems. They're probably running some MPLS traffic engineering as well on their internal networks. And on the left side of this, we have our internal network, which is going to have our routers and our switches. We're going to be running our own interior gateway protocol, and we're going to connect to them via BGP. So what's going on routing-wise here is exactly what you're going to see when you actually connect to via direct connection, or connect to any cloud provider, or connect multiple cloud providers to each other. So when it comes to routing, we have two ways we can do it. We can do static routing, we can do dynamic routing. Here's static routing. Let's say you've got my team. On this call, we've got Chow, we've got Alonzo, we've got Chris, we've got a couple other people. If I've got 1,000 routers, I could tell them to go to each 1,000 routers and tell them which way to go for everything. Now, how many of you guys out there and girls think it's a great idea to manually go to every router and tell every router what to do? Oh, and oh, by the way, as soon as you change something, you're going to have to go to every single 1,000 routers and you're going to change things. Well, thankfully, about 40 years ago, they came up with routing protocols, which were basically the ways that routers would talk to each other to calculate the best path to get there. Kind of like the GPS does in your car. The road's blocked and it says recalculating. Well, that's what dynamic routing protocols do. And internally, we use an interior gateway protocol inside of our systems, and externally, we use an exterior gateway protocol. And there's only one exterior gateway protocol out there, BGP, or Border Gateway Protocol. So when you connect to AWS, you're going to be using BGP. When we're going to be doing VPC peering and a lot of other connections, we're going to use BGP. So you must know BGP. Good news. We wrote a good BGP document for you, which you can download. And I also recommend reading all the Internet Engineering Task Force RFCs, as well as Bassam Halabi's book, Internet Routing Architectures. But for the purpose, and they don't even cover BGP in the AWS Advanced Networking. I wouldn't even touch that. But these are the BGP things that you do need to know. So AWS supports you connecting to them via dynamic routing via BGP. We use BGP because it's scalable, it's tunable. We can do all kinds of really great traffic engineering. If you guys want a BGP workshop, put it down. Chris will let you know, and we'll schedule a BGP workshop. BGP leverages the TCP protocol, and the TCP protocol uses TCP port 179, and it enables organizations to connect and dynamically receive information. Now, obviously, if you're going to connect to a cloud provider and you're using BGP, you need to tell them what your autonomous system number is. They'll have theirs, and that's how BGP determines whether you're internal or external to them. Again, this is way beyond what we can cover in a certification class. But BGP is going to be required when you use a direct connection to AWS. BGP has a lot of tuning options. They used to call them nerd knobs in networking. They're like, Mike, which nerd knob are you going to use? I'm like, I'm going to use all of them because BGP is just cool. BGP has the ability to use communities, which are basically an attribute that gets passed between them that you can match information and take an action on. There's a very common BGP community called no export. AWS supports it. No export means if Chris tells me my information, I don't tell it to somebody else, so they can't reach Chris through me. The AWS BGP implementation is very light. It's not like a complete, robust, full implementation like you would see from Cisco or Juniper Networks. It's good, but it's light. And it supports weight, local preference, AS path, and the specificity of routing information. So it handles basically 100 to 1,000 routes. So address your systems wisely. Otherwise, you'll run out of information. Here's an example of wise IP addressing. Note, you got Mike's data center using the 10/8 address CIDR range. We've got Chow's data center using the 172.16.0.0/ range, CIDR range. And we've got Alonzo's data center, which for the most part is using the 192.168. I only need to send one route to Chow, and she could send that same route to Alonzo, and Alonzo can reach Chow through me because it's eBGP. Likewise, Alonzo only has to send Chow one route, and I only need to know 2 routes, Chow's routes and Alonzo's route, which is 2 routes. So this is addressing and summarizing wisely. That, and thinking about that and planning it takes a lot. So now you know that all your VPCs have a virtual router that's going to handle your routing function. Simple. So does anybody know the other name for a router? It's called the gateway. So let's say you're on the cloud and you want to go connect to the internet because you've got a web server that you want to be reachable, or a load balancer that you want to be reachable, or a VPN concentrator that you want to use for remote access. You need to connect it to the internet. How do you connect it to the internet? With a router that connects to the internet. What's the other name for a router? An internet gateway. So guess what? If you want to connect to the internet, you need an internet gateway. And that's just a router that connects you to the internet. In order to use an internet gateway, it's the same way you would use any other router in any other environment that we've done for the last 30 some years in networking and data center technology. You connect your router to the internet. You create a route, ideally a default route in the cloud because you've got limited routing, that says if you don't know where to go to the internet. You put a public IP address on the router, and you put a public IP address on the systems you want to be reachable behind the router, and poof, everything is reachable. So use an internet gateway, you need to secure your systems. And that means heavy security, not just like WAF or Shield. We can talk about when that would be okay and when it wouldn't when we get to the security stuff. So you can see over here, we've got some EC2 instances or virtual machines. We connect them to the router, which connects us to the internet. That's it. And you can see your 0.0.0.0. That's what a default route looks like. You can see that it's your IGW, your internet gateway with your ID. Now, I actually covered a lot in a short period of time. So let's break it down for some questions, and we'll get into much more flexibility in questions at 5 p.m. on Zoom. But let's get to some questions now anyway. Sorry for any confusion on mine. I mainly wanted to know if subnetting played into VPC connection and how to differentiate routing. So Matthew, subnetting is going to be absolutely everywhere. Everything, every interface you have, except for the interfaces that need to talk to each other, need to be there. You got a server with 3 network cards, you're on 3 different subnets. So BGP is going to, or subnetting will determine how you IP address your systems. If you get that wrong, your systems will crash and not work because it will destroy your routing. If you're going to connect one VPC to another, you're going to have to use subnetting and make sure that your addresses are appropriate. If you want to connect your systems to the cloud, you're going to have to know subnetting. If you want your subnetting to work inside of your data center, you're going to have to know subnetting. There is nothing that can work at all, 0, without subnetting. The cloud is somebody else's network in a data center, so you got to get really good at networking. And that's where 99% of the people go wrong. They want to move to the cloud. They think it's software. They learn all this coding. And we architects, we don't code. But we definitely need to know networking. It is absolutely critical for us. Just no network, no cloud. FB, did I say that we're going to dump IPv6 soon? No. I think we may ultimately at some point soon start adopting IPv6, even though it's been around for 2 decades. We're getting to the point of so many devices needing IP addresses. We don't have that many of them. So at some point, we're going to have to go to IPv6 or something else that's going to work. You always get confused with internet gateway and transit gateway. We're going to get into transit gateway. It's really basically a BGP route reflector. We'll talk about it very soon. But internet gateway is just a router that connects you to the internet. Is knowing eBGP essential in addition to BGP and iBGP? So eBGP is used to connect to external organizations, and iBGP is to connect, to take their information and carry it across your systems. If you connect to the cloud, it's via eBGP. If you're connecting your VPCs together, it's eBGP. So there's no way you're ever not going to deal with both eBGP as eBGP. iBGP is going to be used for people like me when we connect to 10 different internet service providers and we need to carry their routes across their system. So eBGP is big with cloud computing. iBGP is also needed. Talking about routing, well, most of it is at layer 3. So routing is based on the subnet is all layer 3. Now, the routing protocol themselves is actually an application. So some would consider OSPF or BGP to be a layer 7 application, but it's doing, the routing is all done at layer 3. Very good question, Chris. Irie, very good question. Can the IP address range be changed after a subnet has been created? Oh, that gets really ugly. Then you're creating secondary addresses and you're adding a backup network, and then you're building a secondary network, getting the secondary network up and running, and then you got to remove the primary network. It can be done, but it is a major, major nightmare. So it's much better to address it right in the first place than try and clean it up after the fact. But it can be done. And I've spent a lifetime. In fact, I'd say half of the architectures I actually have worked on in the last 25 years, where what happened is somebody would get 10 certifications and they'd think they knew networking, Linux, Python, and they were jack of all trades. They thought they knew IP addressing. They set up the IP addressing wrong, which messed up the routing, and then they would have outages after outages after outages. And the saddest thing was, Augustos, is these folks would be working so hard and they'd spread themselves so thin. So in the matter of getting 10 certifications in 10 different people's careers, they effectively knew nothing because they knew just enough about 10 different people's careers, but not enough to do any one of them well. So yes, I see this all the time. Bad IP addressing scheme, and they got to call a consulting company in. What about NAT or network address translations? There are many, many, many use cases for NAT, and we'll get into them. But while you're here, we ask the questions. We could use NAT to translate a private address to a public address for the internet, and that was usually considered NAT overload or port address translation. We could use NAT when company A buys company B, and they're both using the 10.0.0/8 address space. We could use NAT when we're connecting one VPC to another VPC. So NAT is something that we're using. But the reality is NAT's got 1,000,001 use cases, and it's everywhere. And it's not like what they're going to talk about in the AWS Advanced Networking, which isn't even an intro to junior level networking. And they barely cover it in the Certified Solutions Architect Professional. We're going to be using NAT in a lot of cases. And it's typically with one company bought another company and they need to translate the addresses. Lots of good reasons to use it. Okay, so we talked, so tonight at 5 o'clock on Zoom, we can probably get into a lot. We can whiteboard it out. We'll have some fun. Sign up. Chris from my team will pop a link there. And we'll see you then. But also make sure you come tomorrow. Don't miss the How to Get Your First Architect Job. You know, I've trained architects and thousands of them, and I've got people working in every company in the world, and 99% of the people prepare for their architecture career improperly. And most of the people we get, I'd say 90% of them, already took a boot camp. They already had multiple certifications. They learned coding. They learned Linux. They spent all this time learning Kubernetes. And in the end, they have no idea how to design systems because they learned how to build instead of how to design. Completely different job. So now let's talk. As I mentioned, an internet gateway is a router that connects to the internet, out and in. Coming into your systems is called ingress traffic. Leaving your systems is called egress traffic. So with IPv6, we don't really have a concept of public addresses and private addresses. But what if you have an IP6 environment and you want your systems to go out there to be able to patch their operating system, but you don't want them to be able to, people to come in and hack your systems? Well, we still need some form of an egress gateway, but we come up with, AWS came up with for your IPv6 system, something called an egress-only internet gateway. And what it does is enables your IPv6 address systems to go out to the internet and to receive information, but not to allow external information in, like a firewall, but not really. So it's going to be stateful. So the way it's going to work is, let's pretend my little iPhone with my cute little Cindy on it is the firewall. See, there's a little Cindy. If my traffic goes through the firewall will keep state or keep track of my information going to the internet. And when the web server responds, it's going to hit the firewall, and the firewall is going to say, yes, I've seen it before, allow in. Likewise, traditional external traffic will just be blocked by the firewall, but my return traffic will come in because it's stateful. And the egress-only internet gateway functions very much like the firewall, and it lets your traffic go outbound and come back in, but it doesn't allow external traffic in. So it's great for your IPv6 systems to be able to go out and come back. Now, what is a NAT gateway by comparison? A NAT gateway is an IPv4 version of the same thing. It enables your systems to be able to take their private addresses. It translates them into public IP addresses. And by translating them into public IP addresses, they become public. And then it comes back and the traffic is allowed back. So an internet gateway allows IPv4 systems, then a NAT gateway lets IPv4 systems out to the internet and back. So what is a NAT gateway really? It's really a router with an internet connection that's doing NAT. So keep that in the back of your mind. Now there is also the concept of a NAT instance. AWS is trying to get you not to use a NAT instance. There are times where you'll still need to use a NAT instance, and there's lots of good third-party NAT instances too. And what a NAT instance is a virtual machine that runs routing software that translates one set of addresses into another set of addresses. So you can get a NAT instance that's pre-made from AWS. You can also get one made by routing and switching vendors that has really good routing and functionality and capability. Made by people that's their whole job, making routing. So you can use a NAT gateway, you can build a custom a NAT instance, and it's a good machine. Now, if you use a NAT instance, it's a server, right? And the server is not connected to the internet. So to use a NAT instance, you need the server, and the server will have to have a default route to the internet gateway. So basically that's what's going to be happening. You're going to have your NAT instance, and it's going to have an external IP address on the outside of it. It'll have a default route to your internet gateway, which will have a public address on it. And that server on the inside will be doing the NAT, translating your internal addresses to external addresses. And it's going to look like this. And basically what you're going to see here is as follows. You got your private subnet. You got your NAT instance, which is a virtual machine running routing software in a public subnet. And it's going to go to the internet. And basically these systems will be allowed to go to the internet. The return traffic will be allowed back, but they will not be reachable from the internet. I mentioned a NAT gateway before. A NAT gateway is basically an AWS managed router that does NAT, that's also connected to the internet. And it's going to be given an elastic IP address, which is an Amazon term for a public IP address. It's a public IP address. I would remember it that way. And what you'll do is you'll create a default route. When I don't know where to go to the NAT gateway. It will allow your traffic out and back, but it won't allow internal traffic in. Only an internet gateway will allow that. If you want to see what that looks like, notice before we had the virtual machine and then we had the router connecting to the internet. With the NAT gateway, we've got the private subnet. We connect to the NAT gateway and it sends our traffic to the internet and allows return traffic, but doesn't allow external traffic in. So we need to put network interfaces or network cards. So have any of you noticed that your servers have Ethernet ports in them? Well, normally we call them network interfaces. Well, guess what? If you want a card or an Ethernet card in your server, with AWS, we use an elastic network interface. Like I said, if you don't know what to do in a test question, think about the word elastic in front of what it might used to be called. It's probably the real thing. So basically, all of your virtual machines are going to come with a network card in them. And it's good. The default Elastic Network Interface is going to be called ETH0, pretty common Unix term. Now, if you wanted to, and I'm going to say that you should never create a Bastion host in your life, there is no good reason to use it, and it is a major security violation. So don't make a Bastion host unless you want to get fired and have your replacement thank you for the great job that they're going to get. But the point is, a Bastion host would be a server that you stick on the public internet, and you put two network cards in it. One so you can reach it on the internet. The other is a backdoor violating all your security inside of your internal systems. It's an invitation to be hacked, but it's a dual home system. Now, internally, you might also want to put two network cards in a system to connect that server to two different subnets to allow it to be done on the server without routers. Just keep that in the back of your mind. Don't make a Bastion host. We can show you the more. You already have a direct connection or a VPN to connect to it. You can manage your system securely. So if an Elastic network is a card or a virtual network card that sits in your server, what's an Elastic IP address? An Elastic IP address is a public IP address that's going to exist, and you get it from AWS. AWS owns the address. They have a pool of these addresses. When you need a public address, because you got to put something on the public internet, you use the public IP address. You borrow it from them. They call it an Elastic IP address, and you keep it until you no longer need it. And when you no longer need it, you return that IP address to AWS, and poof, it's yours. It's theirs again. So that's all we're really talking about. Now, normally I would use a load balancer to do this, but in this particular environment, we've got a system that needs to be reachable. So we've got our servers that sit behind a router. They all have public IP or Elastic IP addresses. They connect to the router, which has got a public IP address through the internet gateway, and poof, their systems are being created. Now let's talk about endpoints. Some services in the cloud are in your virtual data center. You own them. Your virtual machine are very secure in your data center. But you may need to reach stuff that's outside of your data center. Now, when you're dealing with the cloud, guess what? The storage is not inside of your data center. You have to, especially for object storage, you have to connect to it. When I connect to DynamoDB, you don't own that. It's not like you put It's not like you put MongoDB in your data center and you own it and control it. It's sitting there, and Amazon's just sort of managing the security. Trust me, it's all good. And for the most part, they're pretty good at what they do. They're great at what they do, actually. But it's somewhere else. So if you're going to go from your private environment to somebody else's, you may use something that's called an endpoint. So endpoints enable you to connect securely. So there are actually two ways that you can connect. You can connect to devices through the AWS private network, or you could go out to the internet, cross the internet, back in the internet, back into AWS. Now, that would cost you security, it would cost you latency, and it would cost you cost because AWS charges you to send your traffic out to the internet. So I want you to look at it this way. There's two options. Let's say you've got an Amazon VPC and an S3 bucket. You could send all your traffic, like we have on the top, all the way out to the internet. Your traffic would leave your VPC. You'd pay for it to go on the internet. It would traverse the internet in a completely non-secure manner, unencrypted, and then it would go back into Amazon. Well, actually, it would be encrypted, but you could do that. Or you could just connect across the Amazon network with an endpoint. So one, you go to the internet, you got all the security nightmares, you come back from the internet. The other is you ride directly across the Amazon network. So that's what an endpoint's used for. And when we talk about VPC endpoints, they are virtual devices for connectivity. And we'll talk about two. They're high availability, meaning they are virtual, which means they're really housed in a bunch of servers. So if a server crashes, they're not going down. And we're going to have two endpoints that we must work with. We're going to have something called gateway endpoints and interface endpoints. Gateway endpoints are high-speed, high-security access to AWS services. What happens is they place a route in the routing table of your virtual router, and we use this to connect to, say, AWS S3. And we'll create an endpoint, and we'll create a prefix list, which will basically say, here's how to reach it through the routing table. You know, we use these endpoints, and we secure these endpoints to secure access from our systems to, say, an AWS S3 bucket. Now, we only provide the routing information to those that need it, because if you don't have a route, you can't reach it. And therefore, we've got some security. We can do other things as well. By comparison, we can create something called an interface endpoint. And this is a different way to connect to other AWS services, like the Systems Manager, Kinesis, if you would use Kinesis, load balancer APIs, for example. We would also use an interface endpoint to connect to an external services, maybe a customer or an AWS partner. And interface endpoints are different than gateway endpoints. With an interface endpoint, with a gateway endpoint like we just talked about, what we're doing is we're putting the route on the routing table to get the traffic to the location that it needs to be. By comparison to an interface endpoint, it's local to our VPC. What happens is we actually create a new network card and a new network interface in our VPC, and we use that to connect to the other VPC. And we'll get an IP address on the endpoint. It will have a specific DNS address. And basically that enables us to create a secure environment to connect to VPCs or to connect to certain services. Now, interface endpoints are going to use something called AWS PrivateLink. For any of you that have been involved in networking and you ever worked with internet service providers and you saw them create frame relay circuits or ATM circuits or VPLS circuits or Ethernet private lines, what they're doing is they're creating a virtual wire. We call them pseudo wires in the networking world that basically takes electrical signaling from a cable and puts it over an IP network. So when you're dealing with an interface endpoint, it creates a private connection for you to connect to whoever your partner is, and via a pseudo fake private line that was created by the AWS network, which means it's secure and it's riding on Amazon's network, which probably has better quality, better access than going to the public internet. And here's what it's going to look like. Here you go. You've got two different VPCs. Now, there's another way we can do it with VPC peering, which we'll talk about it later, but we can basically take our VPC, somebody else's VPC, we can create an endpoint and we can connect to it through PrivateLink. So we're going to get into VPC peering, but PrivateLink creates this equivalent of a pseudo wire to a very specific service. Let's say Cindy the cat has some cat friends and she wants to show her belly fur to only to her cat friends. With PrivateLink, she could only show one service, like the fur on her belly, which is this beautiful yellow and gray, but she could show that to her friends. But it wouldn't show her face, her head, her tail, those kind of things. So with PrivateLink, it's to one service. PrivateLink is also only in one direction, so we have to create it. So Cindy could create a link that says access me, but she couldn't access anybody else. So it gives us much more security, for example. Now, VPC peering, which we're going to talk about in a minute, is going to be a little bit different. VPC peering is I've got my data center, my virtual data center, and somebody else's data center, and we're just going to connect them so we can share everything. So there's a time and a place for that. If I buy another company, I want to share everything. That's VPC peering. Now, let's say I'm an automotive manufacturer and I want to share specific information for brakes. That would be a better link, a better use case for PrivateLink. Now, VPC peering, which we're going to talk about next, will let you deal with a moderate number of connections, 125. What do I think of 125 networking connections? Well, 30 years ago or 25 years ago, I was dealing with 5 and 10,000 networking connections. With AWS, we got 125. Wow. So let's think about that. 125 connections is nothing. It's nothing. So if you've got an organization that has a lot of VPCs, and there might be lots of reasons to create them, we might need to do something different than just standard VPC peering. And we can get into some very cool VPC peering architectures and BGP architectures, but that's way beyond the scope of this. So PrivateLink scales better. And PrivateLink has no limitations other than the speed of your load balancers and servers. Now, if I'm running my VPC and I'm using the 10 address space, and somebody else is also using the 10x address, 10.8/8 address space, VPC peering won't work because we've got IP address overlapping. Now, we could do something behind the VPC peering to make it work, but VPC peering doesn't work with overlapping IP addresses. PrivateLink, not a problem. PrivateLink automatically uses NAT. So it will always find a way to get your systems to talk to the other people's systems for you. So, as I mentioned, VPC peering, which we'll talk about next, is to only 2 businesses to connect to each other, or 2 parts of your organization share everything. PrivateLink is sharing only 1 service. VPC peering is bidirectional. PrivateLink is unidirectional. PrivateLink scales to near unlimited matters. VPC peering scales to 125, which is nothing. So now, what is VPC peering? It's a means to connect your virtual private data centers over the AWS network. So, see, we've got 2 kinds of networks. We've got the Amazon network, which is owned and managed by them. And then we've got the internet, which is this public scary place out there on the internet. So what we're talking is about using the private network to send our traffic, not the public network. So VPC peering is something called non-transitive. It's a test question. VPC peering is non-transitive. I'll explain that to you in a few moments, what that means, but it's non-transitive, just like IBGP. And VPC peering uses private IP address space. And anytime you do any inter-region, meaning VPC traffic, guess what? It's going to be encrypted. So here's your basic VPC peering. You got one subnet, let's say you own that, and another subnet could be another company. Or it could be your London office and your New York office, and you segregated them for security purposes. It's called segmentation. Now, I mentioned VPC peering is non-transitive. We're going to get into that in a minute. Which means we have to do a lot of work to get VPC peering to work. Either we need to fully mesh our VPC peering, which I'm going to talk about that in a minute and show you, or we need to break the rules with a Cloud Hub or a transit gateway. So let me show you what I mean by non-transitive. And this is the IBGP problem. So if any of you people are network engineers or network architects, this will all be similar for you. So in a traditional network, let's assume this is not IBGP. With traditional routing, say OSPF, intermediate systems to intermediate systems, EIGRP, RIP, what have you, we would have all our VPCs, and this is called the hub and spoke environment, just the same way an airplane would be environment, where you go to a hub airport and then they take you anywhere. So let's say VPC in transitive routing, which is not what's going on here, will send its routes to VPC A, and VPC A will send VPC's routes to VPC C, and then VPC A will send VPC's routes to VPC D, and VPC B's routes through A will be sent to E, and F Foxtrot, and G Golf. And by doing so, they can all reach each other because everybody knows how to reach each other. That's transitive routing. Non-transitive routing is because the routes aren't shared. So with VPC peering, because B's routes are sent to A, but A won't send them to C, A can reach B, A can reach C, A can reach D, A can reach E, A can reach F, and A can reach G. But B, VPC P, won't be able to reach VPC C, D, E, F, G through A because it doesn't know about it. And VPC D won't be able to reach anybody other than VPC A. This is because it's non-transitive routing, meaning the routes aren't sent from more than one router away. And this is pretty complicated. So there's a workaround. Here's the workaround. You fully mesh your VPCs. So here in this environment, VPC B is talking to A and C, and therefore C can reach A and B because it's got a VPC peering connection. VPC A has a connection to B and C, so it can reach B and C, and VPC can reach B and A because it has a connection. This is called fully meshed, and it works. Now, this all looks great, right? Simple. We've got 3 VPCs, we've got 3 connections. Here's the problem. Here's the formula for those of you guys that like to get, and gals that like to get geeky on math. The formula for the number of connections we're going to require is n times n minus 1 divided by 2. So here we've got 3 VPCs. So n is 3. So we have n times n minus 1, which is 3 minus 1, which is 2. So we've got 3 times 2, which equals 6, divided by 2. We've got 3. So far, so good, right? Now let's go to 10. We have 10 times 9, because 10 times n minus 1, which is 90, divided by 2 is 45. So we can only create 125 connections. Now we've got 10 of them. We fully meshed them. We've got 45. What happens when you've got 30 connections? So let's just do that math real quick. We've got 30 times 29, which is 870 divided by 2. So if we've got 20 of these things which we're trying to connect, we've got 435 of these connections. But wait, we can only do 125. So you can see that fully meshing is good to a point, but then it doesn't scale real well. It scales horribly. So in BGP, we came up with a really great solution. And in BGP, we came up with a solution, and it was called a route reflector. And let me show you what a route reflector does. A route reflector says, break the rules of non-transitive routing. VPC-B sends its information to VPC-A, which then sends it to C, D, E, F, and D. And then VPC's information goes to A and is sent to everybody. And now we allow for transitive routing. So we've had these problems in BGP for the last 35 years or 40 years or so. So in BGP, we either fully meshed our IBGP peers, or we came up with something that enabled us to break the rules called a route reflector. That's 35-year-old technology. So now we've got VPC peering, and we have the same problem that we had with IBGP. Good news, everybody. We've got a 35-year-old route reflector technology that's going to solve it. And we've got 2 options to do route reflectors or equivalent technology. We've got Cloud Hub, we've got Transit Gateway, and to a network architect like me, they are nearly identical. We'll explain the differences. We're going to begin with Cloud Hub. Cloud Hub is good when you've got multiple VPCs and you want to break the transitive routing rule, and you only are connected via VPN. Cloud Hub only works with VPN. So we can use Cloud Hub to create that hub and spoke environment where everybody will talk to everybody, because it's basically saying break the IBGP rules of fully meshed, which is the same rules of VPC peering. So here you've got a Boston network, a Washington network, and a San Francisco. They're all connecting to this virtual private gateway. We've enabled Cloud Hub, and Cloud Hub enables us to break the rules of transitive routing, and therefore Boston can reach San Francisco through this virtual private gateway. That's Cloud Hub. Cloud Hub enables us to do this with VPNs only. Note that Boston is connected to the gateway via VPN. Washington is connected. Now, that's okay, right? But what if we need guaranteed performance from the Boston network, the Washington network, and the San Francisco network? Now we no longer use Cloud Hub. Now we use Transit Gateway, which from an architecture perspective is essentially the same thing, even though there's some subtle differences. But now we can use private lines or direct connections or other environments, potentially like SASE connections. So realistically speaking, to a network architect, Cloud Hub and Transit Gateway are the same. To a cloud person, one enables you to use private lines, one is only VPN. So there's some subtle differences, but there's a lot of similarities. And Cloud Hub will enable you to use those hub and spoke environments. Basically, Cloud Hub will use BGP, and what will happen is each location will use eBGP to connect to Cloud Hub or Transit Gateway. And by using eBGP, we don't have any non-transitive routing associated like iBGP. So BGP to the rescue. It's technically not a route reflector, but it operates in much this very similar manner. And because we're basically using eBGP, we can set up any policy we want. We can do filtering and things like this to determine who can talk to whom and what. And it is a beautiful, elegant solution. Now here I can show you the equivalent on Transit Gateway. Here we've got a private line instead of a VPN connection. We're connected to the Transit Gateway, run some routing software. It's a virtual router. Poof, there you go. Same kind of thing as before. They used to have a song, I think the Who said it, Meet the New Boss, same as the old boss. Different name, very similar technology, slightly different features and functionalities. Now, we don't want everybody to reach everybody. So we want to be able to protect our systems. Now, when it comes to security, we have to use layers like an onion. You beat one layer, you go to the next layer. Hopefully you got to fight that layer. You beat that layer, you go to the next. You want it to be ever ending where the person can't get in. So on routers, we have the ability to put an access list, which enables us to protect our subnets. On AWS, we don't have a physical router, we have a virtual router. So if we want to protect a subnet, we create the same access list, but Amazon brand named it a network access list, which honestly makes sense because access lists to me as a routing and switching guy are on routers. But Windows also has its equivalent of access lists for users and what they can access via users and groups and identity and access management. So calling it a network access list, I got to give AWS some credit. Very smart decision there. And a network access list will enable us to filter traffic into a subnet. Now, here's the rule with all access lists. Deny. That's the default. Deny. So we must tell them what to permit, or they'll block everything. And the order matters. And because an access list is not like a firewall where it keeps state of what's going in and out, you have to apply it in both directions. So let me show you what not to do. And I've seen this so many times. There's an implicit deny at the end of an access list, or you can put one anyway. But here's the thing. Look at this access list. Rule 1, deny everything. Rule 2, allow port 80 or web traffic in. Anybody have any idea what's going to go here? Rule 1, throw it all away. Rule 2, allow this stuff in. They're processed in order. Rule 1, deny everything. Everything is lost. So what you really want to do is change the order. Allow this, allow this, allow this, allow this, and then block everything else. Hope that makes sense to you. Now, when you ever make access lists, they get numbered. Notice over here how I had a Rule 100 and a Rule 110? Don't make them Rule 100 and Rule 101. Here's why. You make Rule 100, you make Rule 101, and all of a sudden you get hacked from somebody somewhere in the part of the world. You need to throw up another access list. Where are you going to put it? They're in order. You got a problem. Leave yourself space. Notice I did Rule 100, Rule 110. So I could put 9 additional statements in between them because they're processed in order. So really, here's how you would write the same thing. You don't even need the explicit deny in the end. It's implied. But Rule 1, only allow this. That's it. So what's it look like when you put these things? And if the second we put an access law on, the default rule is just deny everything. So here in this particular environment, we've got our internet gateways, our routers, and we're using an access control list, a network ACL, to protect our subnet. So if an access list protects a subnet, a security group is going to protect a service or a host. Which are we going to use? We're going to use both of them, along with many, many other things. So a security group is like a stateful firewall that you put on a server or a load balancer, and it's basically saying what's allowed in. So first, we're going to block the external stuff with a firewall. And we'll talk later about why we would use a next generation firewall versus a cloud provider's firewall, because there's good reasons to do so. But again, it's going to be based on your business case. And we'll talk about, we use the firewalls and all these layers to keep people from getting in. And then we're going to protect our subnets with a network access list. And then we're going to protect our servers with a security group. Now, the reality is there's more that we've got to do to our servers afterwards, but think about it. That's why we're using these things. And a security group, it allows you to create allow rules only. Now, the good news, security groups are firewalls. They are stateful. And by doing so, you put a security group in your server. If the traffic is allowed in via policy that says, allowed to access sending to the cat's website, come on in, when the return traffic goes out, it'll be allowed out because it already knows that it's you. So access lists need to be applied in both directions because they're not stateful. Firewalls and security groups are stateful. They only get applied in one direction. So here's where we have them putting together. Here we've got an access control list protecting a subnet and a security group protecting the servers. So it's a double layer protection. Is that enough? It's not even close to enough. We need many, many, many more layers. So the next thing we'll talk about is a transit VPC. So what is a transit VPC? Let's say we've got two VPCs and we want to connect them to each other, or multiple things and we want to connect them to each other. Remember, we don't have a lot of VPC connections that we can do. Now, if you understand networking, you'll understand that the AWS networking capabilities that it has, think back about 20 years ago. They're still catching up with networking protocols from 20 years ago. In some cases, they're brand new. In other cases, there's a lot of networking missing. But with a transit VPC, we can take a VPC. We could potentially put like a Cisco router or a big, heavy router, virtual router there that's got full routing functionality that we need for modern routing. And we can use it to create it as a conduit where we send our data into the transit VPC, which is different than a transit gateway. A transit gateway is just one thing. A transit VPC is entirely different. So for example, we can have a VPC, and this is just, we would call it a transit VPC. Oops, hold on. And effectively what we would do is we would create our VPC over here. And oops, I don't know what I did over there. We would create another VPC over here. And this VPC over here, this transit VPC, is exclusively designed for routing. And then what we could do is we could use any kind of router we need here, virtual routers with real high performance routing and switching. And that gives us the ability to do heavy duty routing functionality, better traffic engineering, the kind of thing we could do in the data center. It gets us closer to this. And now we're here. And apparently I thought I shared it and I didn't. But what we created here is we created this VPC over here, this transit VPC, and we're going to place high performance. We can place a high performance router there, like a Cisco router, which has full routing code to enable us to do everything. And then we can connect our VPCs to this transit VPC. And now we can connect a whole lot of VPCs to this one transit VPC. And there you go. So Cloud Hub, hub and spoke for VPNs, Transit Gateway, hub and spoke for VPNs, private lines, other technologies, Transit VPC, I need a little bit of flexibility and a little bit of customization and a little bit of control. Do it yourself. Cut them out of the equation for as much as possible. So realistically speaking, we're going to run eBGP to the transit gateway, and data will be coming through. We've got more control over the routing, more control of the switching, and it's there. I'm going to stop there today, and I'm going to answer some questions. Oops, didn't need to do that. Hold on before I do that. I'm going to stop there for right now. So Matthew, as far as the use of an internet gateway, should a firewall be leveraged when connecting to it? Yes. Now, we're not going to necessarily recommend the use of WAF. We're going to recommend next generation firewalls, and I want you to understand why. A next generation firewall has much greater security than a web application firewall, which was designed for web apps. But I want you to understand the difference between a next generation firewall and a cloud provider's firewall, like WAF. In a next generation firewall, it's kind of like if you used your credit card. So I got a new credit card the other day, and I bought like a camera on it. I bought some fancy lenses. And then I went and took my friend to dinner with it. And then my wife was in Philadelphia and she bought stuff. And all of a sudden, the credit card provider sent me a text message. Did you mean to spend this many thousands of dollars in one day? Or they gave me a list of transactions and I said, yes, I spent them, and it was done. They allowed the transactions through. Because they're running something called the heuristics. They're looking at it and saying, did you mean to do these things? Is this a normal pattern of spending? For me, it might be. For somebody else, it might not be. And then after a while, you get that credit card and you're in 5 countries in a week and they're like, okay, Mike travels, leave him the heck alone. Whereas somebody else travels and they go to the Greece for the first time, they go spend money, and all of a sudden it's flagged because it's there. So, it's called heuristics. Next generation firewalls, by comparison, are much like your credit card company. Not only do they have all the cool functionality like WAF of blocking all the stuff that you don't want except for what's allowed in policy, but they're adaptive. They're like your credit card. They're like, this traffic is conforming to policy, but it doesn't look right. Let's just send an alert to the systems and administrators. Let's create an access list on demand. Let's reset the TCP connections, and they're adaptive. And that's why they're next generation. They're self-healing. So if you use WAF, you're going to get alerts via Cloud Hub or CloudWatch. You've been hacked, you've been hacked, you've been hacked, you've been hacked, you've been hacked. If you use a next generation firewall like the kind from Palo Alto or Cisco or Checkpoint or Fortinet, you're going to get a notification. Something's wrong, and then it's going to go fix it for you. So your systems are protected. So all in all, there's very few use cases for me to use WAF other than my cat Cindy's website for tuna. Most businesses that come to me need enterprise-grade protection, and that means next-generation firewalls. So keep that in the back of your mind. We'll get into that when we get into security, and we'll talk about how to get these wonderful, great products from the AWS marketplace or the Azure marketplace or the Google marketplace, and that's how you get industrial-grade stuff on your cloud. Chris Edwards, in a multi-cloud environment where one cloud provider is primary and another used for failover, how will the data configuration be shared with the other cloud? Chris, I want you to think about it this way. You have 2 data centers and they all run simultaneous systems. We can run them both simultaneously, 50-50. And by doing so, Chris, if I put 50% of my systems in Amazon and 50% of my systems in Azure, I've got a couple of advantages. One is if Amazon goes down, who cares? Azure's up. If Azure goes down, Amazon's up. So basically, I'm splitting 50-50, so my price is the same. Now, 2, by using 2 cloud providers, if I've got good business skills, I can negotiate the cloud providers against each other to actually get a lower price. So how does it work? You use virtual machines. You use Kubernetes environments. You don't use any of this, cloud managed anything. You stick your stuff in the cloud and you just synchronize your data. Well, this is no different, Chris, than if you had two offices and they had a wide area network connection between them. It's the same thing. So no different than just having 2 systems. Let's say I have my house, and I actually lived like this, and I lived in next door, my mother-in-law, father-in-law, and brother-in-law lived. It was really great. We got to see each other every day. It was really fun. And basically speaking, I actually could set up a network connection between the 2 houses so that my brother and I could play things without going through the internet. That's all the same thing, and we shared everything. So 2 clouds, generic services, synchronized information, no big deal. I hope I answered your question there, Chris. And the configurations are going to be the same. If it's the same next generation firewall from Palo Alto on both clouds, pretty much almost identical configuration, just the IP address changed. If it's the same Apache Cassandra in both clouds, same configuration. It's just where you put them. Do you put them all in the same room, or do you split them across 2 data centers and have a network between them? So Wesley, the default network access control estate or any access control estate, pretty much everywhere, was always deny anything. Deny everything. Great question. You would buy some Cindy t-shirts to support me. Guess what? I promised you, Wesley, a Cindy photo. I am going to share a Cindy photo right now. I took it the other day with my brand new camera that I got. I'm trying to bokeh out the background. So Chris, if you can share this photo of Cindy in the backyard. Wesley, that's my photo, Cindy. And actually, while we're at it, I want to show you why cloud architects are generally not allowed to configure their technology. I'm going to share 2 more photos. The reason we architects have to stay at the business level instead of actually touching the technology is as follows. Let me close this photo. So the first photo I'm going to show you is a photo that I took in my backyard, Wesley. This is why you can't fly an airplane and keep the people in the seats, and you can't be the architect. So right over here, Chris, if you want to share this was something that happened in my backyard. Sorry, it's an iPhone photo versus a professional camera photo. But here you can see, if you notice in this backyard, right behind where Wesley Rodriguez is, you can see a little squirrel. And that's all you can see is you can see this cute little squirrel. It looks great, doesn't it? It looks safe, it looks happy. And when you do engineering work, you have to be zoomed into what's directly in front of you. Now, by comparison, and I'm going to close this, what was really going on, and then I'm going to get back to questions, is this was what was really going on. Here was actually my backyard. Now, when you were zoomed in to do the engineering work, all you could see was the cute squirrel. Now, this is my sweet little daughter, Cindy, who's sweet to anything other than things that she can hunt. And she was thinking about how to have squirrel steak for dinner. So the engineer that's zoomed in, and they have to be zoomed in to do what's in front of them, can't be doing architecture because he can't be focusing on the business and focusing on the tech. When you do, the squirrel gets eaten. For ACLs example, they were always processed in first in, first out, order, FIFO order, yes. Great. When you were comparing WAF to a next generation firewall, it sounded like I was comparing stateless to stateful. No, they're both stateful. It's just one's adaptive and one's nature. So I don't have a lot of use for WAF. I don't have any, it's very rare that I have anybody that security standards are so low that I could use them. So here's what I want you to think. So Ken, I'd like you to think of WAF as a security guard. It's a security that says, go away, go away, go away, go away, and go away. I would like you to think of a next generation firewall as someone that says, go away, go away, go away, go away. And when someone bypasses that bodyguard or that bouncer, a Navy SEAL comes out fully armed with machine guns that says, are you sure you want to enter? Because if you do, I'm going to take you out. That's the difference between WAF and a next generation firewall. I can't see very many environments in the modern computing world that don't need a next generation firewall, except for small mom and pop businesses that don't have real needs for security. And we can scale out our next generation firewalls like you can't imagine. You don't think the biggest companies in the world are going to be using WAF. They're going to be using something serious. Now, they might use a real firewall and then WAF. So, okay. Mentioned some third-party firewalls versus this. Look, if you have an environment that needs to be secured and it matters, call people that focus on security. And they are people like Palo Alto. They're a market leader in security. They are Cisco Systems. They are Checkpoint. They are Fortinet. F5, the people that have been making load balancers for 20 years, are actually also in security. And there are other security companies, but they are the market leaders. Meaning, probably 85 to 90% of all businesses in the world that are big are all using one of those. Probably 90+%, actually. So, tonight, join us. We're going to have fun. We're going to get on Zoom. We can talk at a lot deeper level than we could in a certification thing. You can ask deeper questions. We'll have fun. My team and I will do the best we can to assist you. I'll bring in people from different backgrounds. Please come tomorrow. Join us on the How to Get Your First Cloud Architect Job webinar. Don't miss that. I promise you, you probably don't understand the architect job. And the reason I say this is I've retrained everybody. And the reality is I want you all to get the best jobs. Plus, there's about $50,000 to $100,000 more or less that you can get in these jobs if you have the right skills. I want you to know what the skills are that are going to get you the $50,000 to $100,000 more per year than the competition. It's going to change you. And Wesley, thank you so much. I love to teach, and I definitely do love anything with fur or feathers. Greg, it's wonderful. Thank you so much for being here. Thank you so much. Appreciate your being here. Mark, thank you so much. I'm honored that you're here. Join us tonight. See you in an hour, and please do not miss tomorrow at 10 a.m. Eastern. Join us. We're going to be on Zoom. We're going to talk about how to get your job. I'll go over the cloud architect job. I'll tell you everything you need to know. I'll give you a full list. I'll tell you how to get hired when you have no experience, how not to get auto-rejected by HR, and then I'll spend an hour and a half answering any career questions you want. So see you tonight. See you tomorrow. Take care, everyone.